It's late, the lights are soft, and the sky outside is doing that slow-breathing thing it does when most people have gone to bed. On the table between us, there's a napkin with a lopsided circle for the sun and a bold, slightly smug slash for a gatecrasher cutting across the neighborhood. They call it 3IATLAS. If names had body language, this one would lean back, arms crossed, like it knows something we don't. We're not here to light beacons or panic. We're here for that delicious middle ground, curiosity with a side of calm. Because this visitor doesn't just wander in. It seems to pick a path like someone who's never been to town, but somehow knows which diner has the good pie and which bar pours heavy. Big, quiet, easy to miss unless you're looking. And the people with very serious telescopes are definitely looking, scribbling notes, lowering their voices, and asking the kind of questions that keep coffee machines employed. No secret handshake, no math quiz, no need to pretend you took a class you didn't. Tonight we're going to walk the line between it's a rock, relax, and what if it's not just a rock? We'll keep our feet on the ground, tilt our chins toward the dark, and let the evidence do the talking while our jokes keep the mood friendly. So, simple question with a big echo. What exactly is 3IATLAS? And why does it feel like it knows more than it's saying? Let's slide our napkin a little closer and put a clean ring of coffee around that lopsided sun. Because our quiet gatecrasher deserves a proper introduction. The name looks cryptic, but it's simple once you peel it open. 3I just means third interstellar, as in the third object we've spotted that doesn't belong to our solar system at all. Interstellar is the key. It's a word that says very casually, I came from another star. Then there's ATLAS, the survey that first caught it, the asteroid terrestrial impact. Last alert system, basically a network of wide-field telescopes that scans the sky night after night to find anything new, weird, or getting a little too cozy with Earth. Picture a vigilant night watch that never blinks. Every clear evening, it sweeps enormous patches of sky, looking for dots that move when the background stars don't. The first time 3I Atlas showed up, it was just a faint, obedient speck sliding exactly the way a speck should. No fanfare. If you've ever scrolled past the most important message of your week because it had a boring subject line, you know the vibe. But faint or not, the motion against the fixed wallpaper of stars is what matters. Stars are so far away, they don't appear to budge from night to night. Anything that does move that's local, comparatively speaking. And when astronomers linked a few nights of motion together, they started to see a path that didn't curl back into a neat loop. Around here, things bound to the sun trace closed tracks. They return for seconds and thirds, like regulars at a diner. 31ATLAS, by contrast, was on a one-and-done line. That's the first hint of interstellar, a track that comes in from far away and goes right back out, not captured by our sun's gravity. Before we dive deeper, a couple of quick translation points so the rest of this feels like plain English. When people say, "oh," they mean astronomical unit, roughly the distance from Earth to the Sun, about 150 million kilometers, or about 93 million miles. It's the ruler astronomers keep in their back pocket. Perihelion is the moment an object gets closest to the Sun in its path. Think of it like the innermost bead on a necklace before the string heads back out. And if we mention retrograde, we're not getting mystical. It just means the object is moving around the Sun in the opposite direction from the planets. You and I are walking clockwise around the rink. This visitor skates on, gliding counterclockwise, head down like it knows a shortcut. Here's what's solid enough to hang a hat on, with the usual numbers maybe tuned as data improves sticker attached. 31ATLAS is big for an interstellar visitor, probably on the order of several miles across, think 5 to 10 miles, roughly 8 to 16 kilometers, with uncertainty because brightness depends not only on size, but also on how dark the surface is. Dark, by the way, is the expectation. Many comet-like bodies reflect only a few % of the sunlight that hits them, darker than fresh asphalt. Its inbound speed relative to the sun is on the order of tens of kilometers per second, say, around 30-something kilometer per second, which translates to roughly 70 to 80,000 miles per hour. That sounds wild, but space is a big, slow theater where fast things still take months to cross the stage. Fast doesn't mean frantic. What really gets professionals leaning forward is the geometry. Once the dust settles on early measurements, you can tell not just that the object is unbound, but how it slices through the neighborhood. The angle of the path matters. The timing matters. The way it threads past landmarks, Mars over here, Earth over there, Jupiter further out matters. And 3IATLAS, if you trace it with your finger, seems to be touring the solar system, like someone who printed a map nobody else has. That's the part we're going to keep circling. Is this just how randomness sometimes looks tidy by accident, or is there something in the way it moves that hints at planning? Before we jump to the deep end, let's separate the 3 baskets we'll use all night. First basket, facts that we observe this stuff. Second basket, hypotheses, our best natural explanations pile. Third basket, speculation, it could be, but we need to be humble about it, territory. Mixing these up is how you turn good astronomy into bad bedtime stories. We'll keep them tidy, promise. Facts first, then. We have a real object on a hyperbolic path. That's the technical word for not coming back. We have a best guess size based on how bright it looks after correcting for distance, and likely reflectivity, with wide error bars because reflectivity is a magician. We have a rotation period estimate, how quickly it spins, usually inferred by tiny, repeating ups and downs in brightness over hours. Think of sunlight glinting differently as it turns. If the brightness swings are small, the shape is probably closer to round than cigar-like. A nearly round shape is common for larger icy bodies. Gravity rounds the stubborn edges as they get bigger. We have an approach that's retrograde, which in practice means it's moving against the traffic of the planets. And we have a calendar, inbound months before its closest solar swing, then outbound toward the dark again. That schedule gives observatories time to point big mirrors and hungry spectrographs toward it. Spectra what? A spectrograph spreads light out into a barcode of colors, like dragging a white beam through a prism and reading the little dips and bumps, where certain molecules have nibbled or emitted light. If there's water vapor near an object, or carbon monoxide, or other common comet gases, you can often spot them. When an icy body warms as it gets closer to the sun, volatile ingredients. Volatile here just means ready to turn into gas, start to sublimate, which is the fancy way of saying ice goes straight to vapor. That makes a fuzzy coma, the pale cloud around a comet's core, and sometimes a tail that streams away from the sun. If 3I Atlas is a natural comet-like thing, that's the behavior many folks expect at some distance. Not necessarily fireworks, but a whisper of gas and dust we can sniff with our instruments. Hypotheses next, the middle basket. The simplest, most conservative reading is that 3I Atlas is a big, dark, icy crumbly object, basically a jumbo interstellar comet, ejected long ago from another star's planetary outskirts. Every planetary system is messy when it forms. Big planets bully little ones. Gravity slings things around, and sometimes chunks are kicked so hard they leave home forever. Over millions or billions of years, those wanderers drift through the thin soup between stars. Most will never be noticed. A few, by pure statistics, will pass through solar systems like ours, their paths shaped by the gravity they meet on the way in and out. Under this umbrella, 3IATLAS's size would help it survive the long trip. Bigger objects lose their outermost layers to radiation and tiny collisions more slowly. Its darkness would match the carbon-rich crust seen on many comets. Its path could be the result of how it happened to enter our sun's gravitational grip. Weird looking, yes, but still natural. That conservative hypothesis doesn't mean boring. A natural interstellar comet is a museum piece on loan from another star. The ices and dust inside preserve chemistry from a different birthplace. Different ratios of hydrogen's heavier cousin deuterium, different flavors of carbon and nitrogen, different layering from the cold where it formed. It's a time capsule sealed in deep freeze. For planetary scientists, that's priceless. As one researcher likes to tell students, interstellar objects are field trips to someone else's origin story. A calm description can still have fireworks in the margins. Speculation now, handled with two hands and a soft voice. A few paths can look suspiciously tidy. If you chart a route that threads close to Mars, when Mars's instruments are wide awake, arcs behind the sun at just the right time, glides within a comfortable but informative distance of Earth, then dips through Jupiter's magnetic kingdom. The magnetosphere is a planet's invisible bubble, carved into the solar wind by its magnetic field. You start to feel like you're reading a travel plan instead of a coincidence. We have to say it plainly, but gently. A probe built to observe a system without being obvious might choose a path that looks a lot like 3I-ATLA's path. The catch is that might is doing heavy lifting. Space is full of patterns that our brains love to see, even when they're accidents. Before we call it a plan, we need more than a neat diagram. Let's bring in voices, briefly and carefully. One veteran observer shrugged to a colleague and said, "If it's natural, it's a gift. If it's not, it's an even bigger gift." Another, more cautious, reminded a conference room, extraordinary is not the same as impossible. You can hold both thoughts on the same napkin. They're not enemies. There's also the memory of our first two interstellar guests to color the room. The first one, nicknamed Oumuamua, was a small, strange visitor, oddly elongated if you believe the models, unusually reflective, and this was the kicker showed, a tiny push away from the sun that didn't line up neatly with the gases we could see. That's where the first modern round of "could it be artificial?" broke into the news cycle. The second, 2I Borisov, behaved like a textbook comet, complete with a graceful tail and chemistry that said, "I formed in deep cold." If those two are bookends, one weird, one normal, then 3I-ATLAS walks in as the thick novel between them. Big, dark, potentially active, and on a route that makes good conversation. Back to the here and now evidence. As it drifts sunward, teams will chase the first whiffs of activity. If water vapor, carbon-bearing gases, or other signatures start to appear at the distances where they usually do, some comets wake up beyond 3 astronomical units, some later that leans toward the natural story. If activity holds off until unexpectedly close, or behaves in a lopsided way that doesn't match the usual playbook, the debate gets louder. Either way, it's data. The sky doesn't owe us an explanation, a dynamicist once said with a smile, but it will give us clues. The trick is to keep our heads cool enough to read them. One more term to tuck under your pillow: uncertainty. Astronomers use it like responsible cooks use salt deliberately and always on the table. When you hear an estimate size 10 miles plus or minus a few, speed 30-something kilometer per second, closest approach on such and such date, there are error bars around those numbers. More nights of watching shrink those bars. Better instruments trim them further. Uncertainty isn't ignorance. It's honesty about how much wiggle room the universe still has in your measurement. Tonight, the wiggle room around 3I-ATLAS is wide enough to invite patience and narrow enough to be exciting. Speaking of patience, the timeline is a kind of plot twist in itself. We have months, not days, to learn. Early on, the object is far and faint, like a match seen from across a football field. As the sun's warmth grows, activity may paint it with a visible halo. After it's closest past its perihelion, The sun's push dwindles, the object cools, and whatever was released thins into the dark. If we're lucky with geometry, the outbound leg lines up with windows when our best observatories can stare. Giant ground-based mirrors for visible light, infrared space telescopes for heat signatures, radio dishes for any hint of long wavelength whispers. Most likely those radio dishes will hear nothing artificial. That's the baseline expectation, but most likely is not certain, and it costs little to listen while you look. There's a quieter piece of the puzzle we don't always talk about: how our own expectations bend the story. Show someone a dotted line that passes near 3 interesting points, and they'll knit a tale. Show them the same line on a different map, and it's just a line. That's the selection effect in human form. In the data, there's a similar bias. We tend to discover the interstellar visitors that pass where our surveys are strongest and our skies are clear. That means we may be seeing the friendly to observe subset of all the paths that exist. If those paths happen to cross the planetary highlights reel, they feel designed, even if a pile of unseen cousins took boring routes we missed. All that said, there's a reason people whisper when they sketch 3 IATLAS's route. It doesn't just pass near things. It does so at moments that make sense for observation. Mars when its orbiters can watch the dawn sky. Earth at a distance that is safe but photogenic. Jupiter close enough to feel the weather of its magnetic bubble. Is that narrative glue or physical glue? Tonight, we admit we don't know. Admitting we don't know is the most grown-up thing we can do in science, right after checking again. Let's keep our promise to explain without drowning you in chalk dust. If we catch gas, it's going to be because sunlight is lifting molecules off the surface. The mix of those molecules, how much water, how much carbon monoxide, how much of this or that acts like a return address. Not a full street and apartment number, but at least this likely formed very cold, or this seems processed by heat, or this has a lot of complex organic stuff, where organic simply means carbon-based chemistry, not life. The patterns across wavelengths visible, infrared, ultraviolet, let us build a little family portrait of the material. If the portrait looks nothing like comets we know, that's not proof of anything exotic. It's just proof of elsewhere. Elsewhere is already fantastic enough. And if we don't catch gas? A giant, quiet, stubborn rock ice mix that refuses to shed even when warmed could still be natural. A tough crust can trap volatiles inside until very close. A spin axis that keeps sunlit patches small can delay activity. Or the composition could be odd in mundane ways we haven't cataloged yet. The absence of a signal is the trickiest clue of all. It invites too many stories. That's why careful teams will combine absence here with presence there, building a case the way a patient detective does, not the way a hungry headline does. Okay, breathe, sip, look up again. Somewhere overhead, the real thing is moving. Slow as a minute hand from our point of view, fast as a highway from its point of view. It doesn't know our arguments about it. It doesn't hear our nicknames. It just answers the sun's pull and its own momentum. That's the honest baseline, and it's beautiful. On top of that baseline, we can layer our careful, if this, then maybe that, logic. If it starts venting gas at a distance, where newcomers usually do, we nod toward natural. If it remains uncannily reserved until it shouldn't, we sharpen our pencils. If its path drifts in a way that can't be explained by gas jets or gravity alone, tiny, persistent nudges that look like course corrections, then the conversation changes from late-night curiosity to history book. Most of all, 3IATLAS is a chance to get better at asking the right questions. What evidence would actually convince us of something artificial? A radio beacon would, repeating unmistakable patterns in light or heat that match engineered systems might. Internal structures with geometry that nature doesn't favor think hollow cavities arranged in grids mapped by clever radar. If we can manage it, would. Short of that, statistics are interesting and worth discussing, but they're not a signed confession. Nature is allowed to surprise us, a comet expert said once, and she usually does when we think we've got her figured out. If you're picturing intrepid little spacecraft racing out to meet this thing, you're not the only one. The practical truth is harder. From idea to launch to rendezvous is years, and interstellar objects don't wait for us to finish our homework. But flyby's quick passes with cameras and sniffers aren't out of the question in the broad sense for future objects like this. Some proposals on dusty shelves suddenly look fresh when an opportunity like 3ITLAS rolls in. If not this one, then the next. Either way, just planning sharpens our tools. And a sharpened tool cuts better when the next chance arrives. So where does that leave our bar napkin detective story at the end of this first deep breath? With a real traveler from another star, big by interstellar standards, dark as expected, moving in a way that's raised eyebrows without crossing any hard lines. With the neat chance to watch it warm, breathe or not, swing by the sun and fade. With a commitment to keep facts, hypotheses, and speculation in their lanes. And with a feeling I think we share, the mix of calm and thrill you get when the theater lights dim and you hear the first notes, not knowing if you're about to laugh, cry, or sit there whispering, "No way," to no one in particular. If 3I Atlas is a natural emissary of distant ice and dust, it will still answer our biggest small question. How ordinary is our ordinary? If it's not just a rock, if it turns out to be something crafted, cloaked to look ordinary in a universe that rewards silence, well, then the oldest human habit, looking up and wondering, will finally have a new chapter to read aloud. Either way, we win the kind of win that keeps you up one more hour. Not anxious, just awake, listening for the next clue to click. Slide the napkin back, because now the story zooms in. Imagine you're one of the night shift astronomers, babysitting a camera that eats starlight the way a photocopier eats paper. Every few minutes, another frame. Stars sit perfectly still in those frames. Anything that isn't a star doesn't. That's the trick modern surveys live on. A small piece of software plays spot the difference like a hyperactive toddler, and when it finds a pixel that moved in a straight line, just enough to be interesting, it pings a human. Most of the time, the ping is a neighborhood rock, an asteroid minding its own business. But once in a long while, the motion you link over a few nights refuses to bend into a circle or an oval. It wants to be a one-way arc, a shape that says politely but firmly, "I'm not from here." That's how 3I Atlas first tiptoed into the logbook. Quiet, polite, and unbound. Interstellar is a big word that can feel like hype, so let's ground it. Our sun's gravity is powerful, but it isn't a jailer with infinite keys. If something swings in with enough speed and from the right angle, it will curve around the sun and keep going, like a car taking a wide exit ramp without ever stopping in town. The line that describes that one-up, one-down visit is called a hyperbola, and you don't need the equation to appreciate the personality. It's the geometry of hello, goodbye. The first giveaway that 3ITLAS is a hello goodbye traveler is that shape. The second is its speed far from the sun. The cruise speed it carries before our star does much say tens of kilometers per second, which is normal for interstellar traffic and too fast to be a casual member of the family. What makes this particular traveler good television is not only that it's visiting, but that it's visiting in a way that gives us time. With Oumuamua, our first interstellar guest, discovery happened after the U-turn near the sun. It was like noticing a stranger only once they'd already left the restaurant. With 2I Borisov, the second, we had more runway. It behaved like a classic comet and showed its chemistry in broad daylight. 3I Atlas feels like a third kind of lesson, big enough to hold heat and secrets, early enough to plan an observation campaign, and quirky enough in its route that even the people who hate drama are side-eyeing the whiteboard. If we could sit the object down and interview it, the first questions would be the obvious ones. How big are you? How fast are you spinning? What's on your skin? What's under the skin? The only way to ask those questions from this far is with light. A light curve is the simple chart of how bright it looks minute by minute and hour by hour. If you see a faint, repeating rise and fall over, say, half a day, that's the spin showing itself as different facets rotate into view. If the rise and fall are tiny, the shape is probably closer to spherical. If they're huge, you might be looking at something stretched out or irregular. 31ATLA sees brightness wiggle, at least in early readings, whispers, not a cigar, which already makes it feel less like Oumuamua and more like the larger, lumpier comets we know. Spheres, or near spheres, are what gravity tends to sculpt when an icy thing gets big enough. Edges soften, pits settle, and the whole mass relaxes into something roundish. Alongside the light curve, color is the second hint. Not paint chip color, but how bright it is in different parts of the spectrum: bluer light versus redder light, visible versus infrared. Carbon-rich surfaces tend to be very dark, reflecting only a few % of the sunlight that hits them. Astronomers call that albedo, and low albedo is normal for comet nuclei that have baked a little and accumulated a crust of complex organics. Organics here is one of those words that sounds like a farmer's market, but means carbon chemistry and nothing more. Life uses organic chemistry, but organic chemistry happens just fine without life. If 3I-ATLA S is as dark as first impressions suggest picture, new asphalt at dusk, then its dimness is not because it's tiny, but because it's wearing the same kind of soot black coat many space snowballs wear. That matters when you convert how bright into how big, because a pitch black bowling ball and a glossy beach ball can look the same brightness from far away, even if one dwarfs the other. Under the hood, the most transformative tool we have is spectroscopy, the way you pull the light apart into its rainbow barcode to see which molecules are there. When sunlight hits ice and dust, and that mixture starts to warm, certain gases escape first. Water vapor is the crowd favorite, but carbon monoxide, carbon dioxide, and a family of carbon-rich fragments often show up early. They leave fingerprints as little bumps and dips at particular colors. When you see those, you can say not only this is alive inventing, but also this likely formed far out in the cold, or this has been processed by heat before, because the proportions of the gases tell a story about temperature history. If you've ever smelled bread and known whether it came from a bakery or a toaster, same idea. Now, why does 3I-ATLA's route keep getting mentioned with a raised eyebrow? Because even the unsentimental folks admit it's tidy. A retrograde approach lets it slice against the traffic of dust and solar wind, which is interesting for sampling. A swing that's close enough to the sun to warm it without sending it into meltdown. A glide that puts it within useful distances of Mars, and later within meaningful distance of Earth. A deeper drift into Jupiter's magnetic bubble, the magnetosphere, the vast region where Jupiter's magnetic field rules the behavior of charged particles. You can tell that natural gravity can do this. It's allowed. But our brains pattern hungry, meaning hungry notice, when the sequence also happens to be a greatest hits tour for observers. The right way to hold that thought is with palms up. In the facts basket, the path we've reconstructed so far, and the distances and timing it implies. In the hypothesis basket, the conservative reading that this is a natural visitor whose entrance angle naturally led to those milestones, aided by good luck and the sheer size of the solar system. Improbable things do happen when you try 1 billion times. In the speculation basket, the quieter thought that if someone did want to build a probe to wander through a system and study it while blending in, the route you'd pick could look a lot like this. As one planetary dynamicist put it in a talk that made the room laugh and then go silent, the universe rolls excellent dice. Be sure it's dice before you blame a dealer. There's a second layer to why people care about this route. It sets up an observation calendar that even insomniacs can love. On the way in, you look for the earliest breath, those first wisps of activity that say, the ice has started to wake. Around the closest point to the sun, the perihelion, you look for the full personality, how violent or gentle the venting is, how symmetrical or lopsided the coma looks, whether jets of gas push the nucleus in measurable ways. After the swing, you watch the cool down, which tells you about how heat travels through the crust and how quickly activity shuts off. If there's a pass that makes Earth-based telescopes happy, you pour on the photons then. Infrared for warm dust and gas, visible light for structure, radio for any long wavelength emissions. None of that presumes anything spooky. It's exactly what you do for a big natural comet. And 3i Atlas is big enough to tempt even the stubbornly skeptical to fight for telescope time. Size matters not because big is dramatic, but because big is informative over time. A small, fragile body can turn on like a sputtering lighter and then fall apart. A large one responds more slowly, giving you physics you can track like a heartbeat instead of a hiccup. If early estimates put 3i-ATLAS in the several-mile club say 8 to 16 kilometers across, with that disclaimer that the number will tighten as we learn, the thermal story becomes a slow simmer rather than a flash boil. That's fantastic for mapping how sunlight soaks in, re-radiates as heat, and triggers outgassing, and for watching whether tiny pushes from uneven jets nudge the path in ways gravity alone can't explain. Those tiny pushes are worth 10 minutes of your attention, because they're the cleanest way to tell rock and ice from rock, ice, and something else. Every comet gets little rocket-like nudges as gas jets switch on and off. The effect is subtle, but measurable if you have a lot of position data. A slight drift here, a drift there, that shows up as non-gravitational acceleration in the math. You don't need the equation. You just need the idea that gravity predicts one graceful curve, and reality draws a curve with a hair-thin wiggle. If 3i Atlas follows gravity plus normal jetting, you get an answer that says, "Thank you, natural world." If it follows a different set of tiny corrections, say, ones that ignore sunlight patterns or turn up when nothing should be venting, you might have to ask weirder questions. We're not there, but it's the right question to have ready. Part of why this is a good bedtime story is that we've seen weird before. Oumuamua looked like nothing we'd predicted. Probably elongated, strangely reflective, and with that tiny outward push that didn't come with the usual gas smell. The debates that followed were healthy and loud. The second visitor, Borisov, calmed everyone down by being exactly what the textbooks expected an interstellar comet to be: active, gassy, dusty, chemically interesting in a clearly from elsewhere way. If you like archetypes, those two give you mystery visitor and model student. 31ATLAS arrives with the bulk of a linebacker and the manners of a visiting professor. It will probably teach without shouting. There's a human question humming under the science question, and it's worth saying out loud because you're probably already thinking it. What would actually count as more than a rock? Not vibes. Vibes are for trailers. The sober answers look like this: a repeating radio pattern that's clearly structured rather than natural, coming from the object and not from Earth. A thermal signature that turns on and off in a way sunlight can't explain. Internal structure with geometry that nature doesn't favor, like hollow volumes arranged regularly, revealed by clever radar, or by how the object rings if struck by solar storms. Course changes that are timed and sized in ways outgassing can't mimic. None of those are easy to get. Most of them are long shots with today's instruments, but it's honest to name them. If an extraordinary claim needs extraordinary evidence, it also needs ordinary checklists, so we don't fool ourselves with poetry. While we wait for data rather than daydreams, there's plenty of natural excitement on the table. The composition of interstellar objects is a Rosetta Stone for how other planetary systems cook their ingredients. Deuterium to hydrogen ratios, how much heavy hydrogen ends up in the water act like climate notes from the freezer where the object formed. Carbon monoxide versus carbon dioxide tells you about temperature history and sunlight exposure. The size and shape of the dust grains in a coma, if we get a coma, point to how sticky the early building blocks were. None of that requires a single what if. It just requires patient photons and sharp instruments. Elsewhere made this, the chemistry will say. Here's how elsewhere works. Double quotes. Now for a gentle curveball. Suppose the object stays stubbornly quiet longer than expected. That doesn't force a sci-fi reading. It could mean the surface has an insulating crust, a sintered layer that space weather fused into hardpan, so the heat takes longer to reach fresh ice. It could mean the spin axis is oriented so that sunlight mostly sweeps across the same tired patches instead of new territory. It could mean the ice mix is unusual, with volatiles that need more warmth to boil off. These are ordinary explanations that have the benefit of being boring and right surprisingly often. The universe prefers simple, has one comet modeler told a room of enthusiastic grad students. Until you can prove it, prefers interesting. If we're lucky, the geometry will set up a few photography days that let everyone on Earth, well, everyone with access to the right images, see something more than a dot. High-resolution snapshots may show jets spitting from the sunward side, soft fans of dust curling back, or a hairline tail that grows and shrinks with solar gusts. Those features aren't just pretty. They're clues to the internal plumbing. Jets come from vents. Vents come from fractures. Fractures form where the stress is high as the object spins and flexes. If the pattern of vents lines up with the rotation in a way that makes sense, score 1 for natural behavior. If we see vents turning on and off when the sun's angle doesn't justify it, that's when eyebrows head north. There's also the social weather to consider, the way talk spreads when the sky serves something unusual. Most researchers are very good at using 3 bins in public: observed, interpreted, and imagined. They'll remind you which bin they're pointing at, like good museum guides. A few voices will make headlines by leaping straight to imagined, because imagined is shareable. It's on us, as curious people who like a mystery before sleep, to keep our own bins tidy. Nothing in those tidy bins takes away the fun. The mystery is already there in the fact that a mountain-sized snow coal from a different star is about to whistle past us and then leave forever. And we get to watch. If there's a single sentence I'd write on the napkin before we turn the page, it's this: our job isn't to make 3i Atlas be interesting. It already is. Our job is to let it tell us how it's interesting, and to be honest about which parts of our reaction are science and which parts are very human hope. If it sheds gas in the ordinary way, it will still give us chemistry from another cradle. If it behaves like no comet we've cataloged, we get to sharpen our natural explanations, or admit we've hit the edges of them. If it does something that makes even the careful people sit back and say, okay, that shouldn't happen, then we rewrite more than a napkin. For now, say we return to the bar in your mind. The glasses are fewer, the table is stickier, the night is quieter. Out there, in a sky most of us can't see past the streetlights, a dark object from a different neighborhood is following a path that our equations drew before it even arrived. That's the calm truth. Layered on top is the maybe truth that makes us lean forward, that the path also happens to be the kind of path a curious mind would pick to snoop politely. Between those two lies the good work of the next month's watching, measuring, comparing, and staying honest about which bin each sentence belongs to. And if you're the kind of person who wants a keepsake, remember that units and uncertainties are the signatures at the bottom of every good note. When someone says closest approach around this date at roughly this distance, that around and roughly mean the team is telling you how much of the line is drawn and how much is dotted. As new data add ink, the dots link up. It's not waffling. It's craft. The cosmos rewards that craft more often than it rewards swagger. So tuck in, let the projector hum, and keep your ears open for those little phrases that matter. First detection of water, unexpected delay in coma formation, non-gravitational component detected, trajectory consistent without gassing. Each of those by itself is a footstep. Together, they're a walk. By the time our traveler takes its last bow near the outer planets and heads out into the quiet, we'll know whether we met a dignified tourist or something with a deeper agenda disguised as dust and ice. Either way, we'll have learned a little more about how to listen when the dark knocks. The Night 3 I Atlas got its first entry in a human logbook didn't look like much. A wide-field camera took a routine exposure, then another, the way it always does snap. Clockwork pause. SNAP, while a pipeline of software compared pixels like a suspicious neighbor peeking through blinds. Stars stayed fixed, the way stars mostly do, on short time scales. But one faint smudge stepped sideways, just enough to break the pattern. The automated system drew a thin box around it, filed a report, and pinged a person. Most pings are false alarms or ordinary rocks. This one, once strung together over a few nights, refused to bend into anything that stays bound to our sun. The curve wanted to be a hello and goodbye. That is, in plain terms, the signature of an interstellar passerby. ATLAS, the survey whose name rides along with this object, is basically an all-sky burglar alarm for moving dots. Spread over the globe, its small telescopes sweep the sky quickly, looking for potential trouble and interesting visitors alike. The sky is mostly a still photo. Anything that smears is a story. As one survey scientist likes to say, the first draft of the story lives in astrometry, the precise act of measuring, where the smudge sits compared to the background stars. Do that across many frames, over many nights, and you can plot a path. Some paths close on themselves like racetracks. Those are homegrown comets and asteroids. Others flare open like exit ramps. Those are the rare ones that came from somewhere else and will head back out. Here's what we know, stated in the boring, beautiful way scientists prefer. The object is faint think magnitude around the high teens to low 20s at discovery, which is too dim for backyard telescopes, fine for survey gear. Its apparent motion against the distant stars matched what you'd expect for something still far out, many hundreds of millions of kilometers from the sun. So you're seeing measured patience rather than a frantic sprint. Fit all those positions with standard celestial mechanics, and the best fit line isn't a family ellipse. It's a hyperbola, the geometry that describes not bound. No equations required. Just picture a swing by that never circles back. What we don't know yet is equally important. Early orbits come with big error bars. Imagine throwing a dart and describing its entire flight from just the first meter of travel. That's how the first week of measurements feels. The cone of uncertainty is wide and tightens as more nights pile on. That's why Discovery teams hand their candidate to the global community fast. The Minor Planet Center, the astronomical switchboard that collects these measurements, shouts the coordinates to anyone listening. Catalina, Pan-STARRS, professional observatories, and talented amateurs all join in. Each added dot on the sky shrinks the cone. By the time enough dots exist, you can say interstellar with a straight face and the kind of caution that records the date and the margin of error. Names, too, have a rhythm. The object's formal tag tells you when and how it was found. The 3I nickname, the I for interstellar, the 3 for third of its kind we've confirmed, is the part your brain will keep. The Atlas bit honors the survey that raised its hand first. If you're wondering why names matter, it's because they anchor the conversation. A name is how you staple a moving dot to a page, so thousands of people can talk about the same thing without waving their hands. Light, parceled out carefully, answers the next batch of questions. A light curve, the wiggle of brightness when the object rotates, can hint at shape and spin. If you watch 3-eye Atlas brighten and dim ever so slightly on a schedule measured in hours, you can infer a rotation period. Early whispers put that period in the ballpark of half a day, with an uncertainty of an hour or so. There's time to refine that. The smallness of the wiggle suggests a shape that isn't wildly elongated. That matters because elongated bodies behave differently under sunlight and gas jets. They can tumble, they can change their faces dramatically. A more rounded world is, in a sense, tidier to model. Color helps too, not paint chip color, but how bright it is in different bands. If it reflects only a few % of the sunlight that hits it, we call that a low albedo. Many comet nuclei are blacker than barbecue charcoal because their surfaces are coated in complex carbon compounds baked by time and light. A low albedo changes how you convert brightness into size. A glossy marble and a lump of coal can look equally bright from far away for very different reasons. Plug in reasonable albedo assumptions, and you get a size range that is large enough to be called a little mountain, not a pebble, something like 8 to 16 kilometers across, with room to revise as we learn whether it's truly soot dark or only moderately dusky. Spectroscopy is where the composition detective work begins. Spread the object's light into a rainbow and look for the faint notches and bumps, the fingerprints of gases and ices. Water vapor is the usual suspect when a comet warms. Carbon monoxide and carbon dioxide often chime in. Some carbon-bearing fragments, tiny, broken pieces of organic molecules, leave their own whispers. The timing of those fingerprints is a clue all by itself. If they appear farther from the sun than usual, it can mean the surface is fresh and ready to vent. If they wait until closer in, perhaps the topmost layer is crusted and insulating. Comets are thermos bottles with leaks. As comet researcher Gerhard Geraint Jones once joked on stage, where and when they leak tells you how they're built. Now to the part that keeps dinner conversations going, the route. The trajectory reconstructed from those nights of data brings 3-eye Atlas in on a retrograde tilt coming in against the direction most planets orbit, then threads it past interesting neighborhoods at distances that are, frankly, convenient for observers. The phrase statistically neat has been thrown around, which is astronomer for huh. The honest framing splits into 3 lanes without turning this into a checklist. Fact: the orbit solution as it stands places close approaches that make sense to pursue with our instruments, with dates and distances that carry uncertainties that are shrinking as we add data. Hypothesis: natural initial conditions approach angle, speed, a timing lottery of where the planets happen to be, are enough to explain the neatness without calling for anything artificial. Speculation: if someone wanted to drift through a planetary system and learn a lot while blending in, a path like this would tick many boxes. It's fine to hold those 3 ideas in your head at once. The key is to label them properly as you sip and think. Extraordinary claims require extraordinary evidence, said Carl Sagan, and the modern version among small-body folks is more pragmatic. Let the photons do the talking. Dr. Karen Meach, who led major follow-up work on Oumuamua, offered a line that keeps showing up in conference hallways. Caution is not the enemy of curiosity. That's the spirit 3IATLS invites lean forward, but keep your pencil sharp. One subtle test waiting in the wings is the search for tiny pushes that aren't gravity. When sunlight heats one side more than the other, and jets of gas switch on, a nucleus can get a small, measurable nudge. Over weeks and months, those nudges show up as a hairline drift from the gravity-only path. If we see that, and the timing lines up with heating and venting, that's natural behavior doing exactly what the textbooks predict. If the object stays quiet past the usual wake-up distance, or shows drifts that don't match the sun's schedule, we revisit our assumptions, starting with the boring ones: an especially tough surface crust, an odd spin axis, an unusual mix of ices. Only after you've tugged on those threads do you earn the right to ask weirder questions. A word on uncertainty, because it's part of the plot, not a footnote. When astronomers say about 170 million miles, or roughly 1.36 astronomical units, the about and roughly aren't hedges. They're guardrails. They tell you where the truth likely lives today and signal that the box will narrow as more measurements arrive. That narrowing is the part of science you rarely see in movie montages. People compare notes, fix small calibration quirks, add new data points, rerun the fit, and watch the error bar shrink. It's slow. It's also how you keep your dignity in front of a universe that loves to surprise you. For now, the most exciting thing about 3I Atlas might be the simplest. We caught it on the way in, not in the rearview mirror. That means there's still time to schedule the good toy space telescopes that see heat, ground telescopes that chew on spectra, even spacecraft already out there that could get a cameo view when the geometry lines up. It also means the public conversation will evolve in real time. Expect headlines to swing from giant alien probe to it's just a rock, folks, and back, powered by half-heard snippets and breathtaking artists' impressions. Under that noise, watch for the phrases that matter. First detection of water, coma onset later than expected. Non-gravitational term detected, spin period refined. Those aren't hype. They're breadcrumbs. If you're listening for tone from the people closest to the data, it's a mix of dry humor and earned patience. Nature does everything before we do. One dynamicist sighed into his coffee at a workshop. We just try to notice in time. With 3IATLAS, we noticed. Now we get to find out whether this dark traveler is simply a time capsule thrown from a distant nursery, or if you'll permit a last wink before the serious stuff resumes, something that knows the bus schedule a little too well. If you squint at a dark sky long enough, brightness starts telling you secrets. It's not glamorous, no choir, no drum roll, just a faint number that says how much sunlight bounced off a thing and made it to our detectors. From that single shy clue, we tried to guess size, surface, and spin. With 3IATLAS, the clue arrived as a whisper, and then got a little louder night after night, until it was brave enough for a first setch. Not a pebble, not a skyscraper, more like a small mountain, keeping to the shadows. Here's the trick in plain English. A dim object can be small and shiny or big and matte. Think coin versus manhole cover in a parking lot at dusk. If both look equally faint from far away, the larger one must be darker. Early color measurements nudge 3I Atlas toward the manhole cover camp low reflectivity, the kind comets wear after a few billion years in the cosmic weather. That matters because when you convert faintness into diameter, a darker coat pushes the solution bigger. With the current assumptions, you land in that 8 to 16 kilometer ballpark across, with a healthy give or take, because albedo, the reflectivity, is still a moving target. Change the coat, change the size. We'll keep updating that number as more light arrives. Now spin. Even tiny worlds turn. If you watch the brightness rise and fall on a schedule, you can back out how quickly the object rotates. 31ATLAS seems to prefer a leisurely half-day twirl call at roughly 12 hours, plus or minus a bit, depending on which chunk of data you trust most. The key isn't just the period, but the modesty of the ups and downs. Big swings would hint at a cigar or a pancake shape. Small swings suggest something closer to rounded lump. No need to imagine a perfect sphere space is not that tiny, but you can picture a potato that's not trying too hard to be dramatic. Rounded bodies are sturdier against sunlight, tugs, and gas jets, which will matter if this thing begins to vent as it warms. Surface color offers another breadcrumb. The spectrum, how bright it is in different bands, leans toward the deep, dull shades comets often wear, blacks and browns more than grays. You don't need to memorize wavelengths to get the meaning. Dark coats absorb heat well. Absorb heat, and your top layer can warm enough to let trapped ices escape as gas. If 3I Atlas behaves like many comets, that warming will switch on a thin atmosphere around it called a coma. Sunlight then pushes the dust into a tail. If it doesn't, that's a story too. Maybe the surface is crusted and tough. Maybe the ices inside are different. Maybe the pores are clogged. A comet researcher once summarized it this way: they're thermoses with cracks. Where the cracks are tells you their history. So, what does big buy you in interstellar space? Two things: memory and stamina. Memory, because a large object can hide a pristine interior away from radiation and micrometeoroids for astonishing lengths of time. Even if the outside millimeters have been sandblasted by cosmic rays and dust, the inside can stay as it was when the object first froze ancient chemistry in cold storage. Stamina, because a bulky body loses those volatiles more slowly. Small shards have a lot of surface compared to their volume. They dry out. A small mountain keeps its cold heart for eons. That's why scientists perked up at the size estimates. A big, dark traveler is a better time capsule than a shiny splinter. We can also talk mass without doing math. If you imagine the interior as a mix of ices, rock, and space between grains more like a crunchy snowball than poured concrete, you're in the right neighborhood. Comet-like stuff tends to be light for its size. A lot of voids, a lot of fluff. Run the back of the envelope conversion, and you get small mountain weight, again enough to sit confidently in the solar wind, not enough to bully planets. The exact number is elastic until we see how it reacts to gravity during a close pass. But the headline holds: this is substantial, not fragile. There's a detail we tuck into our back pocket for later: how heat runs from skin to core. A dark coat warms quickly on the sunlit side and cools in the dark. If the surface is dusty and insulating, the heat may not penetrate deeply before the object rotates and turns that patch away. That creates daily breathing gases, seeping out where the morning warms them, then slowing at night. If the surface is instead fractured or peppered with vents, you can get geyser-like behavior, sudden spouts that act like microthrusters. Those are the tiny, measurable pushes we'll be looking for as 3I Atlas approaches the sun. If a push appears, and if it matches when and where you'd expect vents to be active, it's the most boring and therefore best explanation: natural outgassing. If not, then the dinner talk gets interesting. Comparisons help anchor the imagination. Our first interstellar guest, Aumua, played by different rules, short, bright, weirdly pushy, without a detected coma like a riddle you only saw for a weekend. The second, 2I Borisov, looked and behaved like a textbook comet, coma blazing as it warmed. 31ATLAS, so far, sits between the two in vibe, but not in size. It's stadium scale compared to those earlier visitors, and that alone makes it a different kind of opportunity. A bigger target is easier to study, harder to misread, and may be generous enough to outgas in slow motion rather than all at once. It's also the first of the three we're greeting on the way in, with time to prepare, which turns a curiosity into a campaign. We should also admit what brightness can't tell you. It doesn't reveal what lies under the skin. A crust can be millimeters or meters thick. Pores can be open highways or dead ends. The ice could be water-dominated or spiced with more exotic stuff, like carbon monoxide that wakes up farther from the sun. Each of those choices changes the show we'll see. That's why the community spreads its bets across different kinds of telescopes, some sensitive to heat, some to faint gases, some to dust. If one instrument sees nothing and another sees a whisper, it's not contradiction. It's the outline of a personality. A few short lines from people who live and breathe this help keep our feet on the ground. Don't marry your first model. A small body dynamicist likes to groan in early days. It will break your heart. Translation: treat those size and spin numbers as pencil, not ink. When in doubt, ask the object again tomorrow, says a spectroscopist who has watched comets surprise her for 20 years. Translation: patience multiplies truth. Because the audience tonight is not a room full of specialists, let's keep the labels tidy. Fact: the brightness and color so far point to a dark, likely carbon-rich surface and a diameter better measured in double-digit kilometers than in hundreds of meters. Fact: the light curve wiggle is small, pointing away from extreme shapes and toward a slow, steady rotation around half a day. Hypothesis: those traits match a comet-like body with a crust that may postpone obvious activity until it gets closer, at which point we'll watch for a coma, a tail, and the tiny coarse drift that gas jets can cause. Speculation: a large, rounded, dark traveler is a superb disguise if you wanted to hide gear inside while looking like nature. Nobody can prove that's what's happening, and the burden of proof sits squarely on extraordinary evidence that does not exist today. We can be curious without being careless. There's room for a wink, what if? And room for a shrug, let's see. In the meantime, the practical business is simple. Keep time with the spin, watch the color for changes, measure the brightness every clear night you can, and be ready for the moment when the thermos cracks and the first breath of gas escapes. Whether that happens farther out than usual or closer in than we expected will tell us more than a dozen think pieces. If you're the kind of person who likes a tidy ending, astronomy's rhythm will frustrate you. Objects do not reveal themselves on our schedule, but they do reward attention. 31ATLAS is giving us attention-worthy hints already. Big, dark, unhurried, and possibly conservative with its leaks. That profile, all by itself, makes it scientifically delicious. It also keeps the door open for the after-hours question that brought you here. Could there be more than ice and dust tucked away inside? For now, that lives in the same drawer as all late-night what-ifs. The top drawer, sure, but still the drawer marked maybe. We'll keep the story grounded where it belongs, in the photons that left the sun, bounced off a stranger, and came whispering home across hundreds of millions of kilometers. They don't care about our hopes or headlines. They carry only what happened. Our job is to listen carefully, label what we know, and separate it cleanly from what we're only guessing. On nights like this, with a new character in the sky, that's more than enough. If you want to know whether a stranger is just wandering or headed somewhere, you don't look at their shoes, you watch the route. With 3IATLAS, the route is the headline. From the very first measurements, it was clear this thing is not bound to the sun the way our planets and most comets are. It's passing through, not circling. Astronomers call that a hyperbolic path, which is a fancy way of saying, in one side, out the other, adios. That alone stamps its passport as interstellar. But the way the path threads our neighborhood is where the eyebrows go up. Let's get a couple of road signs out of the way so the rest of the drive is easy. An astronomical unit, AU for short, is the average distance from Earth to the Sun, about 150 million kilometers. Perihelion is the moment an object is closest to the Sun on its path. Inclination is the tilt of that path compared to the flat pancake where most planets travel. And retrograde means moving the opposite way to the planets, like a salmon swimming upstream. 31ATLAS ticks the retrograde box and carries a big tilt, the kind that says it's slicing through the solar system, not politely merging. If you could draw it on our napkin from earlier, you'd sketch the sun in the middle, Earth's orbit as a neat circle, and then give 3I Atlas a bold, slanted line that dives in from high above the plane and exits below it. On the way in, it brushes the suburbs where Mars loops, swings inside Earth's distance at perihelion, then cruises past the giant's territory where Jupiter's influence is king. None of those passes look like a near miss you'd worry about. The distances are big by human standards, tens to hundreds of millions of kilometers. but close enough for telescopes and spacecraft to get good looks. It's the threading the needle feel that makes people say, huh. Now, before we jump to movie plots, there's a calm explanation for everything you just heard. In a city with many streets and millions of travelers, rare alignments happen. In a galaxy with many stars and uncountable rocks and ices, rare alignments also happen. A dynamicist I like to quote shrugs and says, "Nature loves coincidence more than we do." Translation: if you wait long enough, the unlikely shows up, waves, and keeps going. Still, when an unlikely thing arrives, you pay attention. The neat geometry of 3IATLAS gives us a gift: visibility. That tilt means it doesn't hide behind the sun for months. The timetable gives Mars orbiters and Jupiter's Juno a chance to watch. The near-Earth leg gifts us nights where even ground-based telescopes can pull details out of the dark. If you've never heard the term magnetosphere, you will now, because Jupiter's is the biggest bubble of magnetic influence in the neighborhood. It's a wind-blown force field made by the planet's rotation and interior, and it traps particles in belts that would fry most electronics. When 3IATLAS crosses that invisible weather, charged dust and gas around it will feel the twist. If there's any loose material shedding off its surface, Juno's instruments might taste some of it as it rides the giant planet's environment. That's not sci-fi. That's opportunism using a flyby to learn what you can without launching a new mission. On the inbound leg, there's Mars. The red planet has a fleet of orbiters equipped with spectrometers tools that sniff out specific gases by their light fingerprint. If 3IATLAS starts to outgas early, Mars is well placed to notice. And if it stays quiet longer than our normal comets do, that silence is a clue too. Quiet can mean crusted over vents, different ices, or simply a thermal lag, the way the first hot day of spring doesn't melt the lake all at once. The phrase you'll hear from patient observers is, "Wait for the knee." They mean the point where activity doubles, then doubles again, and suddenly the fuzzy atmosphere around the nucleus shows up in images like a halo. When and how sharply that knee arrives is a personality test for a comet-like body. The leg that tempts human nature into speculation is perihelion, happening on the far side of the sun from Earth. That is not illegal. Things happen behind the sun all the time. It's a bright star that tends to photoball. But it does mean our best Earth-based telescopes will have to lean on spacecraft that watch the sun with coronagraphs, those clever cameras that block the blinding disk to see what's around it. If 3I Atlas lights up with a tail then, the coronagraphs will catch the party. If it stays reserved, that's a headline too. Either way, the path puts the critical scene where space-based eyes, not backyard ones, get the best view. Here's where we separate our drawers clearly. Fact: the orbit is interstellar and retrograde, with a steep tilt that keeps it visible much of the way. Fact: the timeline of encounters gives multiple platforms Mars orbiters, solar observatories, Earth-based telescopes after perihelion, and the Juno mission near Jupiter a shot at useful data. Hypothesis: if 3IATLAS is rich in ordinary comet ices, it should breathe more as it warms, and we should measure tiny non-gravitational nudges in its path that match venting. Hypothesis: crossing Jupiter's magnetic environment will complicate any coma it's carrying, braiding the tail in ways we've seen before on solar system comets. Speculation: a route that looks optimized for surveillance from a human point of view may be nothing more than random luck looking like choreography. Unless we see behavior that breaks the rules of gravity, course corrections that don't match outgassing, we don't promote coincidence to intent. If you want a one-liner from someone who spends their life fitting lines to dots, here's a good, boring one. Predictions improve with patience. The person who said it was explaining why early orbit solutions wobble and then settle as the arc of observations grows. We already have a long enough arc to be sure about the interstellar nature and the broad strokes of the path. The small stuff, the delicate tweaks caused by vents, the exact distances at each pass, will tighten as we watch. Every new night adds a thread to the weave. There is also an honest, slightly uncomfortable truth baked into this path. If you were a cautious civilization sending a probe that wanted to look natural, you would pick a trajectory that looks like this because it looks like a lot of other things. Come in fast. Keep your distance respectful. Slide by the interesting targets without ringing doorbells. Use the sun to warm your shell. Use Jupiter's environment to learn about a big magnetic playground, and don't loiter. That is not an accusation. It's a thought experiment. The burden of proof for that story is enormous, and right now we don't have it. What we do have is a route that, coincidentally or not, gives us the best chance yet to study a big interstellar object with many different tools. For science, that's already a win. One more practical piece that matters for your mental map. Speed. 31 ATLAS is barreling along at many tens of kilometers per second relative to the sun. That's highway fast by space standards. When it's nearest the sun, it'll be even faster, because gravity does what gravity does, pulls and accelerates. High speed plus a steep angle is why the whole visit is months of good viewing, not years. It's also why we should send a mission now isn't as simple as it sounds. Building, launching, and matching velocities with something this quick is a tall order. Still, the mere possibility that Mars or Jupiter spacecraft could contribute data. Mid-flyby has engineers quietly inventorying what's possible with the hardware already there. If you're listening for the moment where this becomes definitive, where the narrator says, "And then we knew," this isn't it? The orbit lays the track. The heating provides the test. A natural body venting ordinary ices will tip its hand with a coma, a tail, and a soft drift in the trajectory that fits the timing of sunlight on its turning surface. A reluctant object with a tough crust may hold its breath until surprisingly close to the sun, and then rush the whole performance in a few dramatic weeks. A stranger with technology tucked inside would need to do something that can't be explained by sunlight, vents, or the push of the solar wind. Short of that, the rules say we stick with the simple story that fits the data. If all of that feels like a very long way to say, "We'll see," welcome to astronomy, where "we'll see" is a promise, not a dodge. The path of 3I Atlas sets the table. The rest of the meal depends on how it behaves as the heat turns up. And in the meantime, there's a quiet joy in knowing that for once the universe handed us a trajectory we can follow from the front row instead of chasing after the taillights. If the orbit is the route, the body is the traveler, and travelers come with luggage. What 3I Atlas is carrying is the next big clue. From Earth, we don't scoop a sample out of a cosmic suitcase. We read light. Spectroscopy promise, last big word for a while, is basically a barcode scanner for starlight. Different materials soak up and reflect different colors in telltale ways. So when that faint dot passes sunlight back to us, we can tease out hints of what it's made of. Think of it like listening through a wall. You can't see the band, but a bass line tells you there's a bass. With 3I ATLAS, the bass line sounds a lot like cold ices in dark. Carbon-rich stuff, the same broad family as many comets. Here's where we keep our drawers labeled. Fact, its reflected light looks dark overall. Astronomers call that low albedo, which just means it's bad at reflecting sunlight closer to a charcoal briquette than a mirror. That's normal for comet cores, whose surfaces get cooked into crusty tar over eons. Fact, its brightness rises and falls on a steady rhythm as it spins, like a lighthouse beam coming and going. From that, you can estimate a rotation period without ever touching the thing. And the size? We don't measure it with a cosmic tape. We infer it from how bright it is at a known distance, with some honest guesswork about how black that surface is. Brighter could mean bigger, or just shinier. Dimmer could mean smaller, or just supermatte. So the size has error bars, the universe's version of about yay big. Hypothesis. If the spectrum really shows the fingerprints of water ice and simple organic molecules, the carbon-based chemistry that, out in space, forms without any biology required, then 3I Atlas likely grew up far from any parent star, where temperatures stay low enough for frost to build. Hypothesis. If the spin turns out not too fast, not too slow, that suggests a cohesive body rather than a loose rubble pile. On the other hand, a very slow, wobbly spin could hint at a lumpy shape or a recent nudge. As one small bodies expert likes to say, light curves are personality tests for rocks. Speculation. A very uniform, almost perfectly spherical shape would be interesting, not unheard of, but unusual for a lone wanderer. Nature is a fan of dense. The part that has everyone leaning in is not just what's present, but what might be missing. Solar system comets often announce themselves, as they warm by breathing out certain gases that show up loudly in our instruments. If 3IA-TLA stays weirdly quiet past the point where we'd expect a hiss of vapor, no cyanogen, no easy-to-spot carbon molecules, that's not proof of anything exotic. It could mean the surface has a crust that seals in the ices like a stale cookie, or that its mix of ices is just different from what we're used to. But silence can be a clue, and clues stack. A quick explicable for the bar. When comets wake up, they grow a fuzzy atmosphere called a coma, like coma, a cloud of gas and dust around the solid core. That coma and any tail it grows aren't fire. They're sunlight pushing and charging tiny particles. We watch how that halo brightens and how the tail bends to learn what's evaporating and how fast. If 3I Atlas is normal, heating should dial up its coma in a smooth, predictable way as it falls sunward. If the dial stays stuck, or if it jumps suddenly, we learn something about how its ices are layered, how thick its crust is, or how sunlight gets into cracks. A confession from Team Telescope. Our tools are incredible, but they are still looking through soup. Earth's air blurs. The object is faint. The clock is always ticking. That's why having multiple platforms matters. The James Webb Space Telescope can sniff warm molecules in infrared heat light better than anything we've ever flown. Hubble sees sharp in ultraviolet and visible light. Mars orbiters can watch from a completely different angle during one leg of the trip. Later, solar watching spacecraft can catch the perihelion moment that's too close to the glare for us groundlings. Tie it all together, and you get a composite portrait instead of a shaky selfie. It helps to set expectations. Fact: interstellar doesn't mean alien. Interstellar just means it didn't form here. If you dump a bucket of ice pebbles into a young planetary system, gravity will eventually throw some out. Most of what we've seen supports that story-plane physics, no cloak and dagger. Hypothesis: 3I Atlas might preserve ancient ices with different isotopes, the same atoms, slightly heavier or lighter, depending on how they were forged in old stars. Those subtle differences are the cosmic accent, telling you which neighborhood it grew up in. If we see those accents, that's thrilling science, even if the rest of the story is ordinary. The funhouse mirror in the corner is the what if. What if some of that quiet we mentioned isn't crust or chemistry, but control vents that open in a timed way, not randomly? Heat being moved around inside, not just soaking in? How would we tell? We'd look for nudges in the path that don't line up with sunlight patterns or spin. We'd look for designer outgassing that turns on where the sun isn't shining. We'd listen for radio chatter and expect none. As Carl Sagan reminded everyone forever ago, extraordinary claims require extraordinary evidence. In practice, that means we don't shout craft because a rock is quiet. We'd need multiple lines of weird, all pointing the same way. There's also the matter of texture. Close-up comet snapshots from past missions show surfaces like baked snowdrifts, cliffs, and ponded dust, beautiful, chaotic, very unmachined. We won't get that kind of postcard of 3-eye atlas unless a miracle mission appears. But we can still read texture in miniature. When sunlight hits a rough surface, it polarizes. Think of glare off water through sunglasses. Measuring that polarized light as the object turns can hint at grain size and crust toughness. Fact: several observatories are already doing exactly that kind of polarized light work. Hypothesis: if the crust is unusually compact, the polarization signal could look different from the fluffy coatings we know on long-period comets. Speculation: an engineered shell could mimic a crust's optical tricks. Because if your goal is camouflage, you copy nature's mess. None of this happens in a vacuum well. Physically it does, but you get me. There's a healthy tug-of-war in the community. The cautious camp says, treat it like a new comet until it proves otherwise. The curious camp says, don't blind yourself to anomalies because you're afraid of the L word. Both are right in their way. The tightrope we walk here is to lay out the plain vanilla expectations dark surface. Water ice breathing, a coma that grows with warmth, and keep a sticky note for anything that refuses to fit. One quieter clue worth watching is the spin itself. Sunlight can change a small body's rotation over weeks and months because the warm side re-radiates heat like a microthruster. It's called a thermal push, and it's subtle but measurable if you're patient. If 3IA TLS SE day length drifts in a way that matches the seasons of its journey shortening or lengthening in sync with how the sun hits it, that's a natural signature. If the spin does something out of rhythm, that's not a smoking gun, but it's grounds to make the coffee stronger. So where are we after all that peeking through keyholes? We have a traveler that looks at long range like a big, dark, icy thing, the kind of thing that lives quietly at the edge of star systems and sometimes gets punted into the gulfs between them. We have a path that does us the favor of flying past multiple cameras. We have early hints that line up with comet-ish, and a short list titled, "It'll be interesting if," stapled on top. We will almost certainly watch it shed a little. We might watch it shed a lot, and we might be surprised by when that shedding starts. Surprise, by the way, is not failure in science. It's the good part. If I can bring it back to our sticky pub table, imagine you're watching a stranger take off their coat as they step from a chilly night into a warm room. Do they shake off snow right away? Do they warm slowly and only unbutton after a minute? Do they keep the coat on and pretend they're fine? 31ATLAS is that guest. The room is the inner solar system. We're the nosy regulars, pretending not to stare while absolutely staring. Whether it turns out to be a perfectly ordinary traveler from a faraway town, or the kind of guest who leaves a story you tell for years, the way it wears its coat as it warms will tell us plenty. If the last round was about what 3IATLAs is made of, this one's about how it moves, the part that makes even the quiet folks at the end of the bar look up from their drinks. Orbits are just stories told in gravity's handwriting, and this object's handwriting has a few flourishes you don't always see on the chalkboard. Start with direction. Most things in our solar system go around the sun the same way, like cars on a one-way roundabout. That shared direction is called prograde. Every so often, something barrels through the intersection going the other way. That's retrograde. It doesn't mean wrong. It just means from somewhere else with its own momentum. Fact: 3I Atlas comes in on a steep retrograde track, tilted relative to the flat pancake of planetary orbits we call the ecliptic. Inclination is the angle of that tilt. High inclination means the object slices across our solar system like a skater cutting across the rink instead of following the flow around the boards. For us, that tilt is a gift. It means different observatories get different looks as the object crosses from one celestial hemisphere to the other, like a parade float that passes both sides of the street. There are a few mileposts along the way that everyone circles on the calendar. Perihelion is the closest pass to the sun. the hair dryer moment when ices should wake up and start venting if they're going to. There's also the close enough for good pictures distance from Earth, which is not all that close in human terms, but for telescopes it's like moving from the cheap seats to the lower bowl. And then there's the big planet in the room, Jupiter, with a magnetic bubble, a magnetosphere so huge it would swallow the sun if you could pick it up and move it. Passing through that environment is like flying a weather balloon into a thunderhead. You learn a lot about what you're made of, whether you want to or not. Now, here's where people start using the words choreography and coincidence in the same sentence. Fact: the predicted route threads near several places. We care a lot about for studying different things Mars, for perspective during the inbound leg, the Sun for the heat test, Earth for the post-heat checkup, and Jupiter for the radiation gauntlet on the way out. Hypothesis: if you were designing a single flyby to learn as much as possible about us, you could do worse than a path that hits those beats. Speculation: that resemblance could be nothing more than the human brain connecting dots that just happened to line up. As one dynamicist told me over coffee, the universe has a lot of dice. Sometimes they land in pretty patterns. A quick demystifier on improbable. When someone says a path is unlikely, it doesn't mean impossible or magical. It means that out of many random entries into the solar system, fewer will brush the specific latitudes and longitudes that make our cameras happy. But we also only get excited about the ones we notice. That's selection bias in action. You remember the parade float that waved at your block and forget the 500 that turned down other streets while you were at work. So yes, it's eyebrow-raising that 3i Atlas seems to check multiple science boxes. It's also true that a lot of less newsworthy visitors probably slipped by in angles and seasons that made them hard to see. One more term to keep in a pocket: non-gravitational acceleration. Space rocks don't have engines, but they can still get tiny nudges from sunlight and venting gas. If ice turns to vapor, that vapor sprays off like a micro-thruster and changes the path a hair. If the body absorbs sunlight and re-emits heat more on one side than the other, that thermal push can act like a whisper of wind on a sail. We can measure those whispers. Fact: if 3i Atlas starts venting as it warms, careful tracking should see the tiniest departures from a pure gravity path. Hypothesis: the size and direction of those departures will tell us if the outgassing is patchy or even organized. Speculation: if the course changes in ways that don't match heat or spin, say, a nudge when it's in shadow, or the same nudge repeated at different solar angles, that's when the bar goes quiet. Let's talk Mars. Seeing an interstellar object from the neighborhood of another planet is a rare geometry trick because it gives you a stereo view. Earth sees one angle. A Mars orbiter sees another. Triangulation gets better. If there's the faintest comb of the fuzzy cloud around the solid core, those two vantage points help separate what's real from what's just glare and background stars. The timing around dawn at Mars isn't a spy novel flourish. It's simply good lighting. Low-angle sunlight makes dust and gas pop. It's the same reason you notice your breath on a cold morning when the sun is low and golden. Perihelion, meanwhile, is the main stress test. The energy curve spikes, the surface layers cook, any crust cracks, and ices either take the stage or refuse to. Fact: a typical first-timer comet warms up and starts showing its atmosphere a ways out, and really turns on near closest approach. Hypothesis: if 3i Atlas is sealed under a tougher rind, it could delay that show until later, then erupt in fits and starts. Speculation: pauses and pulses that repeat at a strange cadence could hint at something structural layered ices. Weird pores or, in the boulder read, valves and control. Most of us will start with the boring explanations and try very hard to break them before we reach for the shiny ones. Afterward comes the Earth-friendly leg. Close here still means tens or hundreds of millions of miles. But for the James Webb Space Telescope, that's handshake distance. Infrared spectra after the heat bath can reveal fresh surfaces exposed by cracking, or new molecules cooked up by the sun's UV tantrum. If the coma chemistry changes in a way that tracks temperature and time, that's good old-fashioned comet physics. If the chemistry seems to switch flavors without a temperature reason on again, off again, different again, that's a puzzle worth writing on the napkin. And then Jupiter, the giant. Its magnetosphere isn't a gentle mist. It's a river of charged particles that will sandblast anything that wanders through. Natural bodies show natural responses. Dust gets charged and steered. Gas fluoresces under auroral light. Surfaces get zapped and darkened. If 3I STLAs sheds dust there, instruments built to sniff that dust think of tiny microphone-like sensors listening for grain impacts might get the first direct samples of interstellar grit, even if they're just a few motes. A planetary scientist I pester with what-ifs likes to say, Jupiter is where delicate theories go for stress testing. Hard to argue. There's a side quest running under all this: mass. We don't put things on scales in space. We deduce. Track a body's path before and after a deep planetary pass, and you can read mass from how much the planet tugs it, the same way you'd guess a car's weight by how much it drifts when a truck roars by. Pair that with size estimates, and you get density. Fact: if density lands closer to packed snow than to solid rock, that's a vote for a fluffy, porous interior like mini comet nuclei. Hypothesis: if it's surprisingly compact for its size, maybe its interior has sintered, melted, and refrozen over time, or it's a rubble pile that's settled into itself. Speculation: a density that doesn't make sense with the light we see, too light for too dark, or too heavy for too fluffy, would push us to rethink either our assumptions or the object itself. We should also acknowledge the trickster nature of light curves, those brightness as it spins, graphs that let us sketch shape from a distance. A single smooth rise and fall suggests kind of round. A double hump can mean two big lobes or a squashed potato. Throw in surface patches with different reflectivity, and you can fake a shape that isn't there. That's why multiple techniques matter. Light curves, color changes, polarization, thermal measurements, all cross-checking each other until the consistent picture clicks. As one observer put it in a seminar, no single technique gets the truth. The truth shows up where they overlap. So is the route too neat? The sober answer is that neatness alone doesn't convict or acquit. The sky is big, the sample of known interstellar visitors is tiny, and our instruments are biased toward the flashy cases we can actually study. The honest stance is to keep two thoughts in our heads at once. First, that a natural origin plus smart survey coverage can explain a lot. Second, that if nature is being weird, we don't want to blink and miss it. We're not here to play gotcha with the cosmos. We're here to notice, measure, and admit what we don't know out loud. Pulling back to the pub for a second, imagine a stranger walks in and by chance sits where the bartender can see them, where the security camera has a clear shot, and where the evening sun lines up at the front window. Convenient, yes. Suspicious? Only if they start ordering in Morse code. For 3IATLAS, the orders we're listening for are the tiny course adjustments, the off-season gas, the repeatable oddities that would point beyond ice and rock. Until then, we chalk up the good seat to the roll of the cosmic dice and enjoy the view we were lucky to get. If you've ever boiled a pot of water with the lid on, you know what to expect. A hiss, a fog, droplets on the underside, the whole kitchen turning into a tiny cloud chamber. Comets are the universe's version of that saucepan. Warm them up, and their ice is mostly water, but also other frozen gases, turn straight into vapor and puff outward. That fuzzy halo is the coma. Stretch that cloud with sunlight and solar wind, and you get a tail. It's the comet look we all know from book covers. With 3IATLAS, we arrived at the stove, turned the knob, and then waited and waited, Let's set the baseline without scaring anyone with chemistry class flashbacks. When comets start to turn on, the first glow we often catch is from simple carbon molecules. Astronomers watch for telltale emissions from cyanogen conveniently shortened to C(UN) and a 2-carbon fragment called C2. You don't need to memorize the letters. Just think of them as reliable neon signs. When ultraviolet light from the sun zaps gas around a comet, these little bits light up at very specific colors, and our instruments, which are basically color sniffers, see them pop out from the darkness. That's usually the hint that the lid is rattling. Fact, on its inbound leg, even as 3I Atlas crept closer and the cosmic stove warmed, those neon signs stayed dimmer than expected. Not invisible because our gear is bad dim more, like if they're there, they're whispering. Telescopes that have nailed these signals from much smaller, much fainter comets were left shrugging. A spectroscopist I spoke with put it nicely. Either it's shy or it's different. Hypothesis. There are natural reasons for shyness. A sealed surface can act like insulation. Picture a cream broly crust on top of a very cold dessert. The top looks toasted, but underneath it's still frozen. Some comets carry such crusts, dust, and organics baked into a hard shell that force heat to steal its way inward slowly. In that case, the vapor has to work to find cracks before it can escape. The show would come late, and it might arrive in sputters. We've seen this in a few solar system locals and blamed it on prior heating cycles that baked in the crust. With 3IATLAS, which is a first-time visitor, you'd expect a fresher, more reactive surface. But interstellar travel can do its own baking. Decades and centuries of cosmic rays high-energy particles zipping through space can stitch the topmost layers into something tougher, darker, more reluctant to vent. That would delay the theatrics without any conspiracy required. Speculation. The quiet could also reflect a different recipe entirely. If 3IATLAs formed in a colder pantry around another star, it might be loaded with volatiles frozen gases that don't behave like the mixes we know best. If the carbon chemistry leans toward compounds that don't break into CN and C2 under sunlight, our neon signs won't light even though gas is flowing. Imagine trying to spot a bakery by sniffing for vanilla when this town bakes with cardamom. Your nose isn't wrong, it's just tuned to the wrong spice. There's a second set of clues in the how bright is the fuzz game, and it's less glamorous, but just as telling: dust. When ices turn to vapor, they tend to lift tiny grains off the surface, and those grains scatter sunlight. The coma gets milkier. If gas flows are weak or trapped, dust production lags, and the coma stays tight or invisible. Fact, early images of 3I Atlas looked stubbornly star-like, a pinprick more than a cotton ball. Hypothesis. We'll see the cotton as soon as the sun's heat punches through the rind. No drama, just late bloom. Speculation. If dust appears in strict pulses tied to rotation, say, every time a particular patch faces the sun and heats up that could tell us about the distribution of active spots. If the pulses don't match rotation or sunlight, we'd be in, territory. People love to bring up Oumuamua here, the first interstellar guest that sped away with a tiny extra push but showed no obvious gas. Different object, different size, different everything, but the comparison is hard to resist. Oumuamua taught everyone humility. Nature can look like a magic trick from far away. Some teams argued that exotic ices could produce thrust without the usual signatures. Others suggested thin, sheet-like structure and sunlight pressure. The moral wasn't aliens. It was don't assume the cookbook is complete. So, what do we test now? Without equations, here's the plan on a napkin. You track brightness over time to see if it wiggles with a period. Bright, dim, bright, dim. As it spins, you split the light into colors to look for those signature gas lines. You check polarization, which is the way light prefers to vibrate in one direction after bouncing off dust. Different dust sizes and textures polarize differently, so it's a quick and dirty grain sizer. You watch temperature in infrared to judge how fast the surface warms and cools, which hints at whether you're looking at fluff, rock, or something in between. If those tests tell a consistent story late starting, carbon-poor gas with coarse dust, you chalk it up to unusual but natural. If the story keeps changing scene to scene, you look harder. There's a human trap we should avoid, and it has a fancy name that's also good bar advice: confirmation bias. If you arrive hoping for strangeness, you're more likely to bless any oddity as profound. If you arrive allergic to strangeness, you'll sand down every edge until nothing surprising remains. The healthy middle is boring, but honest. Write down what you measure, flag what you expected to see but didn't, and admit when data are thin. As one observer sighed after a long night, space doesn't owe us clean narratives. A word on uncertainties, because they matter. When astronomers say no CN detected, they don't mean zero. They mean below our current detection limit. That limit depends on distance, how steady the air is, how long you can stare at the same patch of sky, and how much the moon is being a diva that week. It also depends on how fast the object is moving. Smear your target across the detector during a long exposure and you dilute its signal. Fact: the early limits for 3IATLAS are already pretty strict by historical standards. Hypothesis: as geometry improves closer distance, darker skies will lower those limits or finally catch a glow. Speculation: if, after really favorable conditions, those lines stay flat while other things happen, dust rises, temperature jumps, that asymmetry itself becomes evidence that something about the chemistry is different. Let's visit a pet theory in the wilder corner, if only to test the fences. Some folks imagine active camouflage, an object designed to mimic a comet, releasing safe, boring gases on cue while hiding more informative signatures. How would you tell? You'd look for timing that's two perfect gas waking and sleeping on a schedule, tied to observer geometry rather than to sunlight. And you'd search for mismatches between gas and dust. If gas turns on but dust doesn't follow, or if the pattern flips without a thermal reason, you'd raise an eyebrow. Even then, extraordinary claims require extraordinary proof. A few odd nights won't cut it. You'd need a pattern that survives months of scrutiny. Meanwhile, chemistry isn't the only way 3I Atlas can out itself as ordinary. If its coma eventually blooms with the basic comet cologne water, a dash of carbon monoxide, some organics, and if the total brightness tracks the warming in the usual way, you'd have a very large, very interesting, but not supernatural snowball. If, on the other hand, the coma keeps refusing to cooperate, even under heavy heat, people will start sharpening pencils on their alternative models. We don't have to decide tonight, and that's the satisfying part. We get to watch the story unfold in real time. One more practical piece: the role of multiple observatories. Earth's atmosphere complicates chemistry because it has its own CN-ish and C2-ish distractions, and it absorbs some ultraviolet. Space telescopes skip that annoyance. But space-time is precious, so the ground carries the bulk load. The best results will come when ground and space play ping-pong. Ground calls a possible faint line. Space confirms or denies. Ground then piles on longer exposures at the right wavelengths. It's not glamorous, but it's how you turn maybe into got it or nope. And for those of us who like small, crisp quotes to hang on the fridge, here are two I heard this season. From a comet specialist: if it walks like a comet and sweats like a comet, it's a comet, even if it hums a weird tune. And from a radio astronomer staring at a blank spectrum: silence is data too. So where are we really? Fact: as 3I Atlas warms, the classic comet signatures have been subdued compared to what we'd expect from something this big at these distances. Hypothesis: a crusty surface interstellar weathering, or off-brand chemistry could delay or mute the usual glow without any need for sci-fi explanations. Speculation. If prolonged warming still refuses to wake the neon while other indicators flicker in peculiar ways, then we're dealing with either a composition we haven't cataloged or behavior that begs for a more radical rethink. Back at the pub, that means one more round and a promise not to declare the mystery solved just because the night is getting late. The kettle's on, the lid is rattling, maybe quietly, maybe with a rhythm we haven't learned yet. Our job is to keep watching the steam. If the last chapter was us peering at the stove and wondering why the kettle wasn't whistling, this one is the quiet moment where the adults in the room wipe down the counter and say, kindly, let's not call the fire department yet. In astronomy, that kitchen towel has a name, Occam's razor. It's a rule of thumb that says the simplest explanation that fits the facts is usually the best place to start. Not the most exciting, not the most cinematic, just the one that doesn't add extra moving parts without a reason. Fact, the bulk of working astronomers who spend their nights tracking cold specks across the sky think 3IATLAS is natural. A big, dark, interstellar ice and dust object with quirks. Sure, but still a member of the comet asteroid family reunion. They're not being killjoys. They're doing their job. Show them a light in the sky, and they'll first ask if it's an airplane, a satellite flare, a camera glitch, a smudge on the sensor, the moon being dramatic. Only after the usual suspects are lined up and dismissed do they take the next step. Hypothesis, mainstream edition. The oddities we've seen, so far, the softer than expected gas signals, the delayed fuzz, the neat timing of encounters can be stitched together with known physics and a few reasonable assumptions. Interstellar weathering can armor a surface. Different birthplaces make different ice recipes. Trajectories that look too tidy can still happen by chance, because the universe throws a lot of darts, and we mostly notice the ones that land near the bullseye. Speculation, tempered, even if 3IATLAS keeps behaving oddly. Calling it artificial would require a mountain of evidence, not a pile of curiosities. Extraordinary claims require extraordinary proof isn't a bumper sticker. It's a safety rail. Pulsars, those lighthouse stars that tick like metronomes, were nicknamed LGM for little green men when first found, not because astronomers truly believed, but because the signal was so clean it felt engineered. A few years later, the mundane but marvelous explanation won. The universe can do the alien-sounding thing all by itself. One reason the pros are cautious is that space is a bad place for tidy stories. Observations come with shadows. Weather on Earth blurs the view. The target moves. The sun gets in the way. Instruments have personalities. When a team says non-detection, they're really saying, if it's there, it's below X, where X depends on distance, exposure time, background glow, and how many coffees the night operator had. Stack those ifs across dozens of nights, and the honest summary becomes, the pattern looks off, but the paint is still drying. Let's take the trajectory, because that's the part that tempts the inner dramatist. From our pub booth, 3IATLAS appears to thread the needle past Mars close enough for a look, around the sun while it's hidden from most of our telescopes, by Earth at a friendly distance, and then through Jupiter's magnetic bubble, which is like sailing through a planet-sized aurora. It reads like a tour designed for a brochure. A cautious reply is dull but true. The solar system is a big three-dimensional dance floor, and if you watch long enough, some strangers will cross paths in ways that look choreographed, simply because you're standing in a good spot. Selection bias our habit of only noticing the interesting cases. Does the rest? We do not make documentaries about all the interstellar rocks that missed everything and slunk off unnoticed. A dynamicist, someone who plays chess with orbits, put it to me in very unromantic terms. Given enough throws, snake eyes happen. The math behind that shrug isn't hand-wavy. Folks run computer experiments that toss imaginary interstellar objects into the solar system with random speeds and angles, then count how often the fake visitors pass near planets at the kinds of distances we find interesting. The odds can be low and still be real, because space has had a very, very long time to roll the dice. None of this proves 3IATLAS is unremarkable. It just says improbable isn't the same as impossible, and improbable plus headlines isn't the same as designed. Another sober voice comes from the lab bench of comet chemistry. The carbon and nitrogen fireworks we hope to see may lag, but water is stubborn and warmth is patient. If 3IATLAS wakes up later and in the comet world later, can mean weeks of solar heating, then all the early drama deflates into large newcomer with a tough rind. That's a story we've told before. It doesn't get clicks, but it fills textbooks. A spectroscopist friend likes to repeat, absence now is not absence forever. And she's right more often than she's wrong. It's not that the mainstream wants 3IATLAS to be boring. The opposite, actually. A big, pristine interstellar object is a once-in-a-generation gift, even if it's nothing but frozen mud. Every unusual isotope ratio, those tiny mass differences in atoms that act like birth certificates, helps map where and how other planetary systems bake their ingredients. A natural 3IATLAS still changes the recipe books. You don't need aliens to be astonished by a clean taste of another star's pantry. Here's a small but important cultural note about scientists that you can keep in your pocket for any cosmic mystery. Most of them are professionally allergic to certainty on short timelines. That's not cowardice, it's training. If you've ever been burned by the universe, say, by a promising signal that turned out to be a reflection off your own satellite, you build a callus. You learn to say so far, within error bars, pending confirmation. It sounds hedgy to the rest of us, but it's the dialect of people who have to put numbers next to their hunches. That said, caution has a flip side. It can make the field slow to entertain new categories. Oumuamua forced some relabeling. Comet that doesn't look like one wasn't a comfortable folder until it had to be. If 3IATLAS refuses to fit, that folder may get thicker. The healthy path is to expand the catalog of natural behaviors before leaping to engineered ones. Not because engineering is impossible, but because nature has a track record of outweirding us without help. A brief, real-world quotation break, because voices matter. A small-body expert told a conference panel, if it walks like a comet and sweats like a comet, we call it a comet, even if it hums a new tune. A radio astronomer, asked about listening for signals from 3IATLAS, said, we'll check. We always check. But silence is data too. Those aren't dismissals. They're posture. Try, verify, archive, move the needle a little. Where does that leave our central question without killing the mood? Right where good mysteries live, between tidy and tantalizing. Fact, 3IATLAS is real, inbound, big by interstellar standards, dark, and so far less gassy than a textbook comet at similar warmth. Hypothesis. Natural knobs like surface crust, chemistry, and rotation can tune all of that without invoking craft or camouflage. Speculation. If late-stage heating keeps adding energy and the object still dodges, every common signature while doing something else that makes less physical sense, say, changing brightness in ways unlinked to sunlight, then the mainstream will have to stretch. Stretching is not the same as breaking, but it's noticeable. And because this is a documentary for sleep, here's a gentle reminder that even the mainstream leaves room for wonder. Ordinary in space is a galaxy's worth of strangeness by any human standard. A snowball that formed around a star older than the sun, carrying organic molecules that never saw warmth until now, drifting between systems for ages. If that doesn't itch your curiosity, check your pulse. Natural is not a synonym for dull. So we keep watching, not with tinfoil hats, not with crossed arms, but with notebooks. We let the numbers pile up through perihelion, the closest swing to the sun, then through the outbound leg. We let different teams cross-check each other. We let disagreement breathe. We remember that it took years to settle what the first pulsars were, years to sort out the origins of gamma-ray bursts, years to stop calling every fast radio pop a message and start calling some of them magnetars, and some of them, yes, microwave ovens. Space is patient. We can be too. If you want a takeaway to carry into the next chapter, make it this: doubt isn't the enemy of wonder. It's how wonder pays rent. If 3I-ATLAS is just a rock with attitude, it will still teach us how other solar systems cook. If it's not, it will refuse to pass the tests that rocks pass, and the signal of not a rock will get louder the longer we look. Either way, we win a story worth telling. Before we crown 3I Atlas the strangest guest at the party, it helps to remember the last two times we opened the door. Think of Oumuamua and 2I Borisov as the X's your friends always bring up when you introduce someone new. One was mysterious and hard to read. The other wore a bright scarf and told you exactly who they were. Lining them up next to Atlas doesn't settle the argument, but it gives us a cleaner question. Is this the same family with a new personality, or a different species pretending to blend in? Fact first, napkin version. In 2017, Oumuamua Hawaiian for a messenger from afar arriving first, slipped past the sun on a one-and-done path that said clearly, not from around here. No fuzzy coma, that glowing halo comets get, no tail, weirdly bright surface, and a tiny push as it left that didn't match simple gravity alone. Natural explanations piled up. Maybe it was shedding gas we couldn't easily see. Maybe it was a brittle fractal of dust and ice. Maybe a shard of exotic ice that sublimates without leaving obvious fingerprints. Hypothesis. Each of those can, with enough caveats, fit the data. Speculation. If it were a thin engineered sheet of solar sail sunlight, could have given it that extra nudge. Most astronomers filed the sail idea under interesting, but not necessary, and kept working the natural angles. 2 years later, 2I Borisov arrived like the relief pitcher who actually throws strikes. Classic coma. Clear tail. Chemistry that said comet with a twist. More carbon monoxide than we're used to seeing in our homegrown crowd, suggesting a truly cold birthplace around another star. It behaved so by the book that it recalibrated our expectations. Interstellar visitors can look perfectly normal. That matters because it means interstellar isn't a magic word that guarantees drama. It's a mailing address. Now 3IATLAS walks in, and it's neither of those two. It's bigger by a mile literally. By several miles if the early size estimates hold, and darker, a snowball that hides its shine. Its path looks like someone plotted a scenic route with planet overlooks. Its wake-up gases, the usual neon signs we expect as sunlight warms the surface, have been shy or at least slow. If you're keeping track at the pub, Oumuamua was small and clean. Borisov was small and loud. Atlas is large and quiet. Same family, different vibe. Here's why the comparison helps. With Oumuamua, we learned that lack of a coma doesn't automatically mean artificial. With Borisov, we learned that a textbook comet can absolutely be interstellar and still show odd chemistry. With Atlas, we get to test the third corner of the triangle. How does a truly big interstellar object behave under the sun's lamp? Fact, size changes the script. A larger body can keep its insides cold longer, like a roast in an oven. That means delayed outgassing is not weird. It's thermal inertia. Hypothesis. A crust baked by cosmic rays, a steady drizzle of high energy. Particles in deep space could seal in the fizzy stuff until the heat really soaks in. Speculation. If the crust is engineered rather than natural, the timing of any venting might look too neat. Let's talk shapes gently. Oumuamua's light curve, The way its brightness rose and fell hinted at an elongated form. Maybe a cigar, maybe a flat shard flipping like a baton. That made headlines, and fair enough. But we never imaged it directly. We inferred shape from flicker. Borisov, by contrast, was happily blob-like under its veil. Early hints for Atlas lean rounder than needle-like, which lines up with grew up as a big, lumpy snowball. Fact: gravity likes spheres. Give a body enough mass and time, and it tends toward round. Hypothesis: if Atlas is roughly spherical and spins every dozen hours or so, modest, bright, dim swings in Argata make sense. Speculation: a perfectly steady brightness, regardless of angle and heating, would be odd. Geometry usually leaves fingerprints. Chemistry next, with no lab coats required. Borisov's tale told us water plus carbon monoxide plus dust. The comet's starter kit, but with ratios that whispered colder nursery. ATLAS, in the early going, has waved water ice flags in infrared think heat signature without the loud, visible light tracers like cyanogen and diatomic carbon that make comet watchers nod and say, yep, textbook. Fact: different stars seed their disks with different mixes. Our sun's pantry isn't the galaxy's standard issue. Hypothesis: ATLAS's ice could carry isotope ratios tiny mass, differences in elements that point to an older or more metal-rich star than ours. That's not sci-fi. That's forensics. Speculation: if those ratios look too perfectly other, someone suspicious might raise an eyebrow and wonder whether the object is wearing a chemical mask. That's a big leap. File it under fun, not proven. Trajectory: the part that keeps the conspiracy tick-tock spinning. Oumuamua breezed through without flirting with any big planets. Borisov took a warmer dip and showed off. Atlas, on paper, looks like a careful tourist, a pass near Mars where robots can watch, a behind-the-sun perihelion closest approach that conveniently blocks many Earth telescopes, a not-too-close hello to Earth for our biggest instruments, and then a skim through Jupiter's magnetic bubble where our Juno spacecraft lives. Fact: all of that can happen naturally. Random arrivals plus the clockwork of planetary motion will sometimes line up. Hypothesis: we notice the rare tidy paths and forget the messy ones we never saw. Speculation: if Atlas makes even a small unforced course change something gravity alone can't explain, that would be a gear shift moment for the field. One huge lesson from the first two visitors: speed matters. Oumuamua was a hit and run. By the time we all got organized, it was fading. Borisov gave us more breathing room, and we learned to coordinate faster. With Atlas, the community showed up early with a playbook. Schedule the big scopes, split the spectrum among teams, tailor the exposure times, watch across wavelengths from radio to infrared. That means whatever story Atlas is telling, we're better at hearing it. A small body specialist said it simply, "The difference this time is preparation." Quote worth pocketing. Let's zoom out and ask the human question behind all this chart reading. If you're a regular person trying to keep score, what would more than just a rock actually look like in practice? Fact: no single weird thing will do it. The bar isn't odd. It's odd in ways that resist natural fixes after we've thrown the kitchen sink at them. Hypothesis: a cluster of durable anomalies, no standard gases at peak heating. Brightness changes unhooked from sunlight and spin. Trajectory nudges with no plausible venting would push even conservative astronomers to widen the menu. Speculation: the gold standard would be structure edges, repeating geometry, metal with patterns, in other words, the kind of thing you can point to in an image and say, nature doesn't usually draw right angles at that scale. Nobody expects that, but it sets the tone. Extraordinary proof, not just extraordinary vibes. Comparisons also help protect us from the opposite mistake, overcorrecting into boredom. If you label everything a rock, you'll miss the whale surfacing behind the boat. That's why people did float the solar sail for Oumuamua, and why some are comfortable saying out loud that a TLA's path is eyebrow-raising. Exploration needs both pedals, the brake of skepticism and the gas of curiosity. The trick is pressing them in rhythm. So, where does the ledger stand when you put all three visitors on one page? Oumuamua taught us that interstellar objects can be dry on the outside and still be natural. Borisov taught us interstellar comets can look delightfully textbook while carrying traces of a different childhood. Atlas is teaching us right now how size and timing complicate the picture, and it's giving us the longest runway yet to do careful, boring, beautiful science. If you love the alien angle, that's not a downer. It's a filter that makes any future. This is different, claimed Sharper. One more tiny, honest note about uncertainty. If a TLAS turns on its comet switch in dramatic fashion near perihelion big coma familiar gases, don't be disappointed. That doesn't erase the months of learning. It just means the plot twist arrived later in the episode. And if it doesn't, be patient with the people whose job is to kill their own favorite ideas before the data does. A radio astronomer put it best. We plan for the mundane and leave room on the schedule for miracles. We'll end this round with the simplest summary that still respects the mess. 3i Atlas looks like family, talks like family, and for now, keeps a few secrets the older siblings didn't. That alone makes it worth your attention. Whether it's only a rock with an interesting accent, or a visitor wearing a perfect costume, the next weeks of heat and the long outbound leg will tell us more than any pub speech can. If the last chapter was family portraits, this one is about luck and how terrible we are at judging it. People hear 1 in 20,000 and imagine a miracle. Statisticians hear it and ask, out of how many tries? Space gives you a lot of tries. Planets keep circling, the sky surveys keep scanning, and interstellar strays keep bowling through the lanes. Every now and then, pins line up. That's the vibe around 3IATLAS's too tidy route. It looks curated Mars peak, sun curtain, Earth hello, Jupiter finale, but tidy patterns can grow out of honest clockwork if you watch a big enough clock. Let's unpack that without napalming the wonder. Fact: planetary geometry is predictable. Mars and Earth and Jupiter are locked in a dance we can draw centuries ahead. Drop a visitor into that choreography at enough random angles, and a small fraction will thread the highlights by accident. Hypothesis: because we mostly notice the threads that graze our interests near Earth. Near our spacecraft, we amplify their specialness. That's selection bias, the brain's habit of circling the one red jelly bean and ignoring the jar. Speculation: if an advanced engineer wanted to hide in plain sight, they'd lean into that bias and choose a path that looks barely coincidental, just plausible enough to shrug off. So what would actually separate lucky from guided? The cleanest tell isn't the route, it's the steering. Gravity draws smooth curves. Gravity doesn't do zigzags, as one orbital dynamicist likes to say. If a TLA drifts exactly where the math says it should, you can call the path unlikely but natural. If, on the other hand, we measure a course change that doesn't fit any shove we can blame on heating and venting, then the room gets very quiet, very fast. That's where outgassing complicates the detective work. Comets make tiny thrusters all by themselves when sunlight warms a patch and jets of vapor blow out. To us, those jets can look like invisible finger taps on the trajectory. With Oumuamua, a faint non-gravitational push lit this whole debate. With Atlas, the stakes are bigger because the body is bigger. Fact: a larger, heavier object is harder to budge. Any jet that could meaningfully steer, it should also leave other fingerprints, like a change in spin or a whiff of familiar gases. Hypothesis: if we see a nudge with no matching spin tweak and no chemistry to blame, the natural thruster card gets harder to play. Speculation: a smart craft could hide its pushes behind the sun or during noisy windows, timing tiny corrections when our instruments are least sensitive. That's why the calendar matters almost as much as the coordinates. The behind-the-sun segment perihelion, when Earth's view is dazzled, looks like a magician's flourish. It is also perfectly ordinary celestial geometry. Both can be true at once. A defense against storytelling is prediction. Before Atlas rounds the sun, teams publish where it should land on the sky if gravity is in charge, down to skinny error bars. Then we check. If post-perihelion positions fall outside those bands in ways you can't rescue with thermal models, you've got something spicy. As Carl Sagan loved to remind us, extraordinary claims require extraordinary evidence. Hitting or missing those bands is the evidence part, not the adjectives. Meanwhile, the instrument crowd is stacking the deck for clarity. The Vera Rubin Observatory will track brightness like a heartbeat monitor, looking for any subtle stutters that don't line up with spin or phase angle. The James Webb Space Telescope will sniff the warm side of the spectrum, where even modest gas leaks glow. Ground radio arrays will listen in the quiet bands for anything narrow and persistent. Most natural things smear across frequencies, while electronics tend to prefer very tidy channels. To be clear, nobody expects a beacon. What matters is pattern and persistence. Fact: nature loves broad, messy noise. Hypothesis: if you find a line that holds its tune across days and follows Atlas on the sky, that's not a smoking gun, but it's not boring either. Speculation: even a whisper could be interference from Earth or a satellite. So the first job after AHA is to try very hard to debunk yourself. There's another trick for telling steering from sweating. Watch the spin. When comets vent, they often torque themselves, speeding up or slowing down like an ice skater pulling in their arms. If Atlas shows a trajectory nudge, but keeps an eerily steady rotation despite heating, the bookkeeping gets awkward. Conversely, if the spin wanders in step with any drifting, that points back to natural jets flickering on sunlit patches. A comet scientist summed up the vibe nicely. If it's sweating, it's turning. That's testable, and it's why boring. Repeated light curves night after night after night are secretly the most dramatic part of the show. Let's talk probabilities for a minute without turning this into homework. When you read about 1 in 10,000 odds for a trajectory, you're looking at a very specific question with very specific guardrails. Like asking the chances you pull exactly the 3 of hearts after someone stacked the deck against you. Change the question slightly. Allow the 5 of hearts, or any heart, or any red card, and the odds balloon. In space terms, if you demand this distance to Mars on this day, you get a tiny number. If you allow any close Mars pass within a month, the number swells. Fact: good teams publish their constraints, so other teams can sanity check the math. Hypothesis: the more we widen the window to reflect what would have seemed equally impressive had it happened, the less supernatural the odds look. Speculation: if after fair widening the numbers still scream rare, that rarity simply marks a great target, not proof of intention. There's a softer bias we have to name too. We love purpose. Give us a line and we'll look for the hand that drew it. That's fine for stories and risky for science. The fix isn't to ban wonder. It's to delay conclusions until the measurements box us in. The practical version of that is a ladder of claims. Interstellar visitor is a low rung. The orbit says hyperbolic, done. Unusual chemistry is the next rung. Spectra say so with error bars. Non-gravitational acceleration is higher. You argue about models and subtle systematics. Artificial origin is the roof. You don't step out there unless the structure underneath is concrete. This is why you'll hear cautious voices sounding, well, cautious. They're not here to kill the mood. They're building the ladder. All of this can feel like moving goalposts if you're rooting for the big reveal. So let's set a fair bar in plain language. If Atlas erupts with a textbook coma near the sun, shows familiar gases, and its path hugs the gravity line within published uncertainties, The natural visitor box wins the night. If instead, it stays chemically odd at peak heating, sneaks in a course correction that refuses ordinary explanations, and keeps a stoic spin while being baked, the conversation legitimately shifts. Neither outcome wastes your attention. Both teach us how interstellar stuff works, which is the point. A planetary scientist put it this way: if we're wrong with good data, great, we're less wrong tomorrow. There's one more reason to be publicly picky. The field learned the hard way with Oumuamua that once a dramatic narrative takes off, it's nearly impossible to steer it back with footnotes. The antidote is real time, open predictions followed by public scorekeeping. That's happening now with a TLAS. Ephemerides, the sky maps of where it should be, are posted for anyone to check. Observing logs go out in preprints. People argue in daylight. If there's a deviation, you won't need to take anyone's word for it. You'll be able to see the mismatched dots. And if you want the romance version to close your eyes with, here it is without cheating the facts. Somewhere between stars, something old and dark drifted for ages. It reached our street at an angle that gives us a show. We're watching it the way you watch a stranger cross a town square, checking the pockets, the pace, the glances. If it's only a traveler, we'll still learn what travelers from that road carry. If it lingers on a corner, it shouldn't. If it walks against the crowd with intention, well then, the square will feel different for a very long time. For now, the job is simple and strangely beautiful. Predict, watch, compare, repeat. Luck will handle itself. Purpose, if it's there, will have to show its work. Let's run the pub table thought experiment all the way. If 3i Atlas were more than a rock, what would more actually look like, and what would leak through our telescopes, no matter how good the disguise? We'll keep it grounded. Facts where we have them, hypotheses where the dots almost connect, and speculation where we're drawing in pencil. Start with size, because size is destiny in space. Atlas is big by interstellar visitor standards, about 7 miles across. Give or take a mile depending on the model. Fact: a body that large is naturally great at shielding whatever sits inside it. Cosmic rays and micrometeoroids chew up small things over millions of years. A mountain of ice and dust shrugs a lot of that off. Hypothesis: if anything artificial needed to nap for eons, this much mass is a perfect blanket. Speculation: a hollowed core think, thermos inside a snowball, could hide instruments and heat without cooking the outer shell. We can't see inside directly, but radar or careful light curve tricks, how the brightness wobbles as it spins, might hint at an internal cavity if the spin and the mass don't add up cleanly. A comet researcher once told me, nature packs lumpy. Engineers pack tidy. That's a testable vibe. Power is the next headache. Interstellar trips don't come with charging stations. Fact: sunlight out near Jupiter's distance is weak, about 1/25th of what Earth gets, and drops fast as you head outward. Natural comets don't need power, they just ride and sublimate when warmed. Hypothesis: if Atlas carried electronics, most of the voyage it would run off something steady and miserly. Radioisotope heaters, little nuclear batteries, stored chemical energy, or a reactor designed to sip. Speculation: any serious reactor dumps heat, and heat is hard to hide. We'd look for a thermal hotspot in mid-infrared during the cold approach or after sunset sides, something warmer than a sun-warmed snowball should be. If we never see such a spot within instrument limits, that argues for either no power-hungry guts or very clever ways to leak heat that mimic gentle outgassing. Then there's the how do you talk home question. Fact: nothing beats light for long-distance messaging, and light takes time minutes across the inner solar system, years between stars. Hypothesis: a cautious probe would store data quietly and beam it later with a tight, needle-thin signal to somewhere prearranged in the sky. Maybe when Earth can't see, like during that behind-the-sun stretch. Speculation: Jupiter's neighborhood is interesting, not just because it's dramatic, but because its giant magnetic field can bend and trap charged particles. If you wanted to test antennas or piggyback a signal in radio-loud terrain, passing through the magnetosphere on purpose would be a great stress test. We'd hunt for narrow, stable tones that ride along with Atlas on the sky. Natural plasma burps are messy and broad. Engineered systems tend to be neat and steady. To be fair, neat and steady can also mean some human satellite or ground interference, which is why teams do the unglamorous work of ruling out our own noise first. Sensing, what could it be here to measure? Fact, from 170 million miles away, Earth is a bright dot with a spectrum, not a postcard. But that spectrum is chatty. Oxygen, water vapor, and methane stacked together in a way that screams active planet. Hypothesis. A patient watcher could also test for more telling. Molecules trace industrial gases like chlorofluorocarbons that don't hang around naturally. They're faint, but a big enough mirror and a long enough stare make faint things talk. Speculation. The bright side pass near Earth could be about eavesdropping on our radio leakage EV carriers. Radar pings, satellite chatter. Fun twist. Humanity's accidental radio bubble has been getting quieter as we switch to fiber and spread spectrum signals. A modern recon probe might prefer to read our sky glow and satellite traffic patterns rather than AM radio dramas. Camouflage matters if you buy the Dark Forest playbook. Fact. Atlas's surface looks dark and non-reflective, which is exactly what we expect from space-weathered organics and dust. Hypothesis. The safest disguise isn't paint. It's genuine material. If you assemble the shell from real ice and dust, maybe even harvested from a natural body, you get authentic chemistry for free, right down to the weird off-solar system isotope ratios. Speculation. That shell could be engineered to sweat on cue, bleeding a little water vapor to pass the sniff test near the sun. The catch is coordination, sweating in a way that fools every instrument, while also doing sneaky maneuvers is hard. We'll be looking for mismatches outgassing without torque, heat without chemistry, a stable spin while the path bends. Navigation is the quiet superpower. Fact. We fly our probes with Star Tracker's little cameras that recognize constellations and keep the craft oriented. Hypothesis. If anything wanted to thread Mars' dawn, hide behind the sun, and skate Jupiter's magnetosphere, you'd need a guidance system that updates itself after millions of years of drift. Stars move. Maps go stale. Speculation. The map could live in math instead of memory. Look up. Pattern match the sky you see to the sky you expect. Adjust. A living star atlas in code, not ink. Would we see signs of that? Maybe only indirectly, as course corrections too clean and well-timed to blame on natural vents. How about durability? Fact. Space is a slow grinder. Ice develops crusts. Dust sinters. Solar wind scuffs surfaces into something like asphalt. Hypothesis. A long-haul probe would embrace that, letting the shell turn into armor. Speculation. Inside, you use self-healing materials, the sci-fi idea that's actually showing up in our lab's resins that reflow under heat, electronics that reroute around dead lanes. None of that leaves a headline in a telescope, but it fits the thermos in a snowball model and changes what we'd expect thermally. High thermal inertia. Meaning it warms and cools slowly and keeps a weirdly even temperature across day and night. That, too, is measurable. Collection is the fun part. Fact. Atlas's retrograde path plows upstream through the solar system's dust and wind, boosting the number of particles it meets. Hypothesis. A collector could sit just under the surface, letting the shell take the hits while filters grab tiny grains and ions for analysis. Speculation. Some of those filters might then be cooked and sniffed during perihelion, when there's plenty of solar power, with results compressed into a future data burst. If that's true, perihelion becomes less a moment of risk and more a pit stop, Let's be picky about alien tech would be obvious. It might not. Dr. Jill Tarter's evergreen reminder, absence of evidence is not evidence of absence, cuts both ways. Fact, a lot of engineering, especially smart engineering, is about not leaving fingerprints. Hypothesis, the best sign of intention is not a laser or a logo. It's a pattern of choices that consistently privileges safety, information, and concealment over everything else. Speculation, in a universe of natural messines, sustained tidiness is its own kind of signal. So what would move the needle for sober folks? A short checklist, no fireworks. First, a non-gravitational nudge after we've exhausted outgassing models, timed when we couldn't watch. Second, thermal behavior that refuses to match a dark, porous snowball, either too even or too warm, at times when the sun can't explain it. Third, radio behavior that is narrow, persistent, and co-moving, verified by multiple facilities and ruled out as our own. Fourth, internal structure hints a mass that's low for the size or spin stability that seems engineered rather than battered together. Each alone is interesting. 2 or 3 together start to feel like a story. But remember the other story that's at least as exciting. We caught a pristine piece of someone else's protoplanetary backyard. If Atlas blooms near the sun with chemistry that doesn't match our comet's different deuterium ratios, unfamiliar organics, that's a win for science, not a loss for mystery. One planetary scientist told me, the universe is generous. It gives you more than one way to be amazed. That line belongs on a t-shirt. In the background, you can hear the philosophy humming. Arthur C. Clarke's third law gets quoted to death. Any sufficiently advanced technology is indistinguishable from magic, but the second half of the thought matters just as much. Good science is indistinguishable from humility. We lay out predictions in the open. We fail loudly when they miss, and we let the sky decide. If Atlas is a rock, it's the most interesting kind. A courier from another star with a chemistry set and a travel journal baked into its core. If it's more, it won't stay shy forever. Purposeful things eventually leave purposeful traces. Either way, the next acts are practical. More light curves to watch the spin, more spectra to chase shy gases, tighter ephemerides to nail down the path, radio shifts scheduled during the noisy and quiet hours. The romance is there if you wanted the idea of something old and watchful passing through our yard, but the discipline is the point. We've built instruments that can catch a lie at 1 billion miles. All we have to do is keep asking fair questions and accept boring answers when they're true. And if you're still peeking over your shoulder at the sky, same. Me too. That's not paranoia. That's curiosity doing its job. If you really want to test the could be more than a rock idea, the fairest thing we can do is turn the telescope around on ourselves and ask, if humans had a century of extra engineering under our belt and a deep need to stay invisible, how would we build something that looks exactly like 3I Atlas and send it on the same kind of tour? No magic, no hand-waving, just a blueprint you could pitch to a very paranoid, very patient space agency. First constraint is the costume. You don't fake a comet with paint. You fake it with the real stuff. Fact, the outer solar system and interstellar space are full of dark, carbon-rich dust and ice that naturally weather into something blacker than charcoal. Hypothesis. You'd mine or hijack a genuine icy body, maybe a small, dull comet, and let nature do the finishing. The more authentic the shell, the fewer tells you have to micromanage. Speculation. If you needed more space, you'd add mass by snowmaking, spraying water vapor that refreezes into porous frost, building your snowball layer by layer until you hit that mountain-sized silhouette. A planetary scientist I once interviewed put it this way: if you want to beat spectroscopy, use the universe's own recipe. Hard to argue. Inside that shell lives the reason for the trip, and heat is the enemy. Fact, electronics hate extremes, but they hate being seen even more. Hypothesis. You'd tuck your payload inside a vacuum bottle-think spacecraft nested in a thermos with long, skinny heat pipes that wick waste heat outward and bleed it through the surface as slow, natural-looking warmth. Speculation. You'd synchronize the bleeding with sunlight cycles, so the whole body warms and cools like an honest snowball. No bright dots, no late-night hot flashes. If you do it right, an infrared telescope shrugs and says, "Looks like a rock having a day." Power is the next non-negotiable. Reality check. Sunlight alone is a tough sell in the cold and dark, and fuel that lasts a million years isn't a product you can buy. Fact. We already fly radioisotope power systems, little nuclear heaters that trickle electricity for decades. Hypothesis. Scale that idea up modestly and marry it to miserly computers that hibernate most of the time. The shell itself becomes your radiation shield. The thermos walls keep heat from spiking. Speculation. During work windows, perihelion warmth, magnetosphere crossings, close approaches, you wake the instruments, sprint, and sleep again. A rhythm of sips, not gulps. Navigation isn't swagger, it's humility. Stars move over long times, and maps go stale. Fact. Spacecraft today use star trackers cameras that recognize constellations as if the sky were a QR code. Hypothesis. You'd upgrade that into a self-correcting atlas. Compare what you see to a built-in model of stellar drift. Update the model. Repeat. Speculation. You could even read the background glow of our galaxy to double-check your orientation when bright stars aren't where your ancient map swears they should be. No noisy thrusters, just occasional micropuff-steiny symmetric taps that look like ordinary outgassing to anyone not paying insulting levels of attention. Communication is where most science fiction falls apart, so let's keep ours boring and plausible. Fact. Tight beam lasers make for whisper-thin messages across absurd distances, but aiming them is like threading a needle from another city. Hypothesis. You don't phone home constantly. You cache data and transmit only at pre-planned sky positions, when your target star system is where your antenna can point without Earth catching the glint. Speculation. If you're extra careful, you bounce signals off. Nothing, you push them straight through interstellar dark. At wavelengths our all-sky surveys rarely patrol, and only for minutes at a time. Talk rarely, talk quietly, as one radio astronomer told me. Then he added, with a smile, "And don't talk near nosy neighbors." Sensors decide what story you'll tell when you finally talk. Fact. From the outer solar system, Earth is a bright dot whose light carries chemical fingerprints. Hypothesis. You'd feel two kinds of instruments passive. Sniffers that taste dust and solar wind as you plow upstream on that retrograde path, and patient eyes that stare at planetary spectra until the faintest features crawl above the noise. Speculation. Near Jupiter, you ride the magnetic highway, sampling charged particles that have spent time around moons with oceans and volcanoes. Near Earth, still at a polite distance, you watch the night side for our artificial sky glow, not our daytime chatter, because city light leaks in ways radio no longer does. Planets betray themselves at night, a climate physicist once told me. I wrote it down and underlined it twice. Camouflage has to be more than skin deep. It has to be boring. Fact. Real comets tumble a bit, shed a little, flare a little, then settle down. Hypothesis. You'd script a light curve that looks natural slight wobble, nothing acrobatic, and you'd let the shell shed dust at a rate set by sunshine, not by your schedule. Speculation. Your course tweaks would be rare, tiny, and timed when the sun sits between you and our telescopes. Any push you do give yourself would be symmetric, so you don't change spin in a way a grad student can catch at 3 in the morning. The enemy isn't NASA. It's that grad student with stubbornness and a spreadsheet. Could humans actually build this within sight of our current tech? Here's the honest split. Fact. We've flown long-lived power, star trackers, smart autonomy, and sample sniffers. We've even built spacecraft that operate for decades in hostile radiation, like Juno at Jupiter. Hypothesis: the thermos in a snowball design is engineering, not witchcraft. With enough mass on the outside, the inside can be as quiet and cozy as a server room. Speculation: the real chasm is time. We build for decades. A serious interstellar courier might need to survive for millions of years. That's not just better parts, it's a philosophy. Redundancy like coral reefs. Systems that forget their own scars and keep going. Now, take that blueprint and lay it over a TLAS. Does anything already rhyme? The retrograde path that swims upstream through dust is perfect for passive sampling. The far side of the Sun perihelion is a convenient moment to stretch without eyes on you. The post-perihelion pass at a comfortable, non-alarming distance from Earth is a flattering distance to do remote sensing, and the later skim through Jupiter's magnetosphere is a physicist's playground. None of these prove intention. They simply mean a cautious mission planner could look at the current ephemeris and say, if I wanted to be nosy and careful, I could work with this. But a blueprint is a Rorschach test, unless you tie it to measurements. So what would our engineer's eye look for next? You'd lean on the unsexy stuff. How fast the surface warms and cools across day and night. Whether the spin stays rock steady through perihelion stress. Whether any faint, narrow radio tone appears and vanishes with a geometry clock rather than a chemistry clock. Whether dust shedding near the sun lines up with sunlight like a textbook or refuses to. None of this requires drama. It requires patience and, frankly, the courage to publish null results. As Dr. Michelle Bannister likes to remind students, we learn a lot from things that stubbornly refuse to be interesting. There's an ethical layer here too, and it's not just for alien civilizations. If you or I were writing press releases, the easiest play is the loud one. But that's not the pact we made with curiosity. Fact: big claims draw big attention and leave big dents when they're wrong. Hypothesis: the most useful story we can tell is the one that keeps both doors open. Natural relic or deliberate machine, while we build the diagnostics to close one without drama. Speculation: if there is intent inside that snowball, it's already factored our theater into its risk model. Nothing we say changes what it does. What we can change is whether we make the next generation more careful or more cynical. And if, in the end, Atlas turns out to be gloriously, stubbornly natural, that's not a consolation prize. That's a museum exhibit delivered to our doorstep. Its ice remembers a different star's baby pictures. Its organics might carry variations on the chemical alphabet that wrote our own biology. We can be thrilled by that without needing a pilot at the wheel. The universe doesn't owe us company to be worthwhile. As one quiet spectroscopist told me in a hallway, alien tech would be neat. Alien chemistry is inevitable. I know which one I can publish this year. Here's the paradox we live with happily. The more disciplined we are about not jumping to conclusions, the more prepared we'll be if a conclusion jumps to us. If Atlas is only a courier of ancient snow, our measurements will sharpen the story of how planets everywhere come to be. If it is, against the odds, a courier of intent, the sane measurements, the boring ones, the careful ones, will be the ones that catch it out. So we keep the napkin drawing on the table, we keep the jokes handy, and we keep the bar tab open for as long as the sky will have us. Curiosity isn't a switch you flip. It's a posture. You lean forward. You listen. You don't interrupt. And when the guest finishes their drink and stands to leave, you say thanks, whether they were a stranger with a good story or a scout with a mission, because either way, they made the night better. Here's the moment where the napkin sketch gets circled 3 times and we decide what story we're actually telling. We've met 3-eye Atlas in dim light. We've guessed at its motives, like detectives peering through a keyhole. And now we're close enough to line up everything we know without tipping into bedtime sci-fi. The question on the table stays the same. What exactly is 3I ATLAS? And could it be more than just another rock? But our answer needs backbone, not goosebumps. Start where the floor doesn't move. Fact: this visitor is big for an interstellar object, roughly 11 kilometers across, about 7 miles. Give or take a mile, depending on how dark its surface actually is. It rotates gently in something like half a day, not the frantic pinwheel you'd expect from a lightweight shard. Its surface is jet dull, reflecting only a few percent of the sunlight, which is normal for old ice and carbon-rich grime. Spectra those rainbow fingerprints say water ice is in the mix, plus a cocktail of organic chemicals that space cooks up all by itself. None of that screams machine. It whispers frozen time capsule. Then there's the path. Fact: Atlas is on a hyperbolic retrograde track, which just means it isn't bound to our sun, and it swims upstream against the traffic of the planets. That's standard for a wanderer from outside. Less standard is how the path threads the needle and early brush past Mars, a closest approach to the sun on the far side from Earth, a polite glide past our planet at a respectable distance, and a long exhale through Jupiter's sprawling magnetic bubble. You can call it luck, you can call it choreography. The math doesn't care what we call it, only how rare it is. Now, the itch you can't quite scratch. Fact: at distances where some comets already start breathing, we haven't seen the usual early gases, those easy-to-spot molecules that flare up when ice warms. That might be timing. It might be crust. It might be compositional weirdness from a star system, not like ours. Hypothesis: if Atlas lights up closer in, with water vapor and dusty sunlit curtains, the big natural comet label fits like a glove. Speculation: if it stays stubbornly quiet even when the sun is baking it hard, then either it's a kind of comet we don't have a file on yet, or the outgassing is being managed in a way that won't give itself away. Here's where the room splits. On one side, the working astronomers with the scar tissue of 100 false alarms. They reach for the sharpest razor in the drawer. The simplest explanation that fits the data gets the nod until something breaks it. They're not boring. They're disciplined. Nature is inventive enough, one comet expert told me. It doesn't need our conspiracy theories. On the other side, you have the handful of voices saying, "Don't rule out what you haven't tested." That's not waving a flag that says alien. It's marking a box that says unproven. So how do you keep both groups honest? You make a short list of clean, decisive moments, not the TV drama ones, the measurables. When Atlas rounds the sun, does it warm and shed dust in a way that follows sunlight like a metronome? Do we hear any narrow radio tones that flick on and off with geometry rather than chemistry, say, only when Earth is in a particular slice of the sky? Do we catch tiny course corrections that don't align with pressure from sunlight or symmetrical outgassing? Does the spin keep its cool through the heat, or does it twitch in ways a hidden thruster could explain? None of these tests require belief. They require patience and an appetite for the dull edges where truth hides. There's a trap on each side of the debate. If you're hungry for a visitor with intent, you can turn coincidences into clues and drift into wishful pattern spotting. If you're allergic to sensationalism, you can file off the corners of real anomalies until nothing surprising remains. The middle lane is narrow but walkable. Let the object tell you what story it wants to tell by how it behaves under stress. Planets, comets, probes, everything gives itself away under stress. Let's translate that to plain stakes. If Atlas behaves like a natural comet at close solar range warming curves that match sunlight, gases that appear in the expected order, dust that flares with predictable timing, the case for big, old, natural becomes heavy. The size turns into an asset, not a smoking gun. A larger body keeps its interior cold and untouched for billions of years, which is exactly what we'd hope for if we want to read the chemical handwriting of another star's nursery. A result like that isn't a letdown. It's a library card. We'd be staring at ice that remembers conditions far from our sun, maybe older than Earth itself, preserved like a note in a bottle. But if Atlas never acts up, even when the heat is on, if it skims through perihelion with an infrared profile that looks oddly even, if the dust, when it finally shows, refuses to track the sunshine, if the spin stays immune to the kinds of turquoise that natural jets produce, then you have a stack of behavior that needs a new chapter, not a new religion. Extraordinary claims need extraordinary evidence, as the mantra goes, but extraordinary patterns deserve extraordinary scrutiny. That's the promise and the risk. As Dr. Jill Tarter likes to remind anyone with a microphone, keep an open mind, but not so open that your brain falls out. It's a joke with a steel spine. There's another way to state the climax that isn't romantic, but feels right. We are about to learn whether Atlas fits inside the bag of tricks we already own. If it does, we upgrade our models of how other star systems build icy giants and spit them into space. If it doesn't, we upgrade the bag. Maybe we add a new class of interstellar object with surfaces altered by cosmic rays into something reluctant to vent. Maybe we stumble into material science. We didn't predict ice is bonded into structures that release energy differently. Or maybe, in the quietest corner of possibility, we detect a signpost that says, "This was designed to be boring." Not a message, not a hello, just a signature in behavior that chemistry can't counterfeit indefinitely. Either way, there's a human climax here that doesn't depend on the verdict. We've built a global orchestra of eyes and radios and patient code that can notice a moving smudge across the sky and within days pull together a plan that involves Chilean mountains, Hawaiian domes, an infrared giant parked beyond the moon, and a humming probe over Jupiter. That's not sci-fi. That's Tuesday. The object brought us a puzzle. We answered with a symphony. The universe favors the prepared mind, a teacher wrote on my lab's whiteboard years ago. It's corny and absolutely true. So what do we say tonight, at this very table, before the final measurements nail things down? We can say what we know, what we think, and what we're willing to imagine, and keep those 3 lanes clearly painted. We know 3i Atlas is large, dark, and on a one-time pass through our house at high speed. We know its path happens to stroll past the showpieces, Mars, the sun's bright porch, Earth at a decent distance, Jupiter's electric curtain. We know it hasn't yet put on the classic comet performance this far out, which is odd but explainable. We think it will answer a lot of our questions near the sun, where ice decides whether to stay quiet or sing. We imagine responsibly that if it refuses every cue we've learned to expect, then we may be standing at the edge of a category we haven't named. And if you're asking whether it could be more, here's the cleanest answer I can give without wasting your time. It could be, not because we want it, but because the space of what's possible is wider than our checklists. The job is to tighten the could. If more means a type of natural object we haven't cataloged, that's a big win. If more means a machine wrapped in winter, that's a different kind of win and a different kind of morning after, the kind with memos and meetings and careful words. In both futures, we're not powerless spectators. We get to do the measuring that makes one future more plausible than the other. What's beautiful, at least to me, is that curiosity pays out regardless. If Atlas sheds, we learn how alien chemistry draws its letters. If it stays hushed, we learn where our models are weak. If it blinks in a way that looks timed rather than warmed, well, then we've got a measured reason to knock on the door of the extraordinary and ask to see some ID. No fireworks, no capital letters, just the evidence walking in front of us, step by step, until even the skeptics nod or the romantics relent. So lean forward with me, one last time tonight. Picture the smudge becoming a disk in a spacecraft's camera, a spectrum turning from noise into lines, the light curves settling into a rhythm you can tap on the table. Picture a room full of people who have staked their careers on being careful, allowing themselves one small smile, because the universe gave them something it never had to, a clean test. That's the summit we've climbed to no flag yet, just a view wide enough to make the next step obvious. When 3I ATLAS clears the sun and heads for that Jupiter rendezvous, we'll know which shelf to put it on, or whether we need to build a new shelf from scratch. And if, in the unlikeless twist, we do confirm intent, don't expect drama. Expect quiet procedures, more measurements, and a lot of new students applying to astronomy grad school. The cosmos won't change because we finally noticed someone else in the dark. We will. And that's the real point of nights like this, realizing that the question, what is it, is always also, what are we to be asking? The pub is closing. The napkin has more pen grooves than paper left, and our mysterious guest is already edging toward the door. Before we let 3I ATLAS slip back into the night, let's say out loud what we've learned, what we're betting on, and what we're still brave enough to wonder about. No trumpet blasts. Just the quiet click of a story coming to rest. If you pressed me for the cleanest version, I'd start with the pieces that don't argue. We are tracking a large interstellar object, roughly 11 kilometers across, about 7 miles, with a couple of miles uncertainty, because its surface is so dark, it hides its true size in the glare. It spins slowly, roughly once every half day. It reflects little light, on the order of a few percent, which is typical for ice and dust that's been space-tanned by radiation for longer than our species has had shoes. The rainbow fingerprints in its light show water ice, plus a family of carbon-based compounds that chemistry in cold places produces without needing anyone's help. Its path is hyperbolic, which means it isn't bound to our sun. It came from away, and it will leave the same way. And the geometry of that path happens to slide past Mars, dart behind the sun from our point of view, give Earth a respectful berth at tens of millions of miles, and then lean into Jupiter's huge magnetic umbrella as if it had heard the tour guide's highlights. Those are the facts, stated in plain clothes. Now comes the knot that won't untie itself by wishing. We haven't yet seen the early, easy gases that many comets show when they warm up far from the sun molecules that tend to shout long before water does. That absence could be about timing. Some comets hold their breath until they're closer in. It could be about skin. Radiation can bake a crust that keeps the interior from venting until it's forced to. It could be about origins. Ices grown in a different stellar neighborhood may release different signals at different temperatures. None of that is science fiction. It's patience. But if the sun cranks the dial and Atlas stays strangely quiet, then we've got behavior that doesn't match our cookbook. And cookbooks are meant to be rewritten when dinner doesn't taste as expected. This is where people tend to split into teams, and I'm going to propose we don't. The careful crowd repeats a line you'll hear in any good lab. The simplest explanation that matches the measurements keeps the chalk until something erases it. The adventurous crowd answers with another solid rule. Don't throw away a possibility you haven't tested. Those are not enemies. Together, they're a decent compass. As one planetary scientist told me over a cracked coffee cup, surprise is not a synonym for alien. Then she added, with a grin small enough to miss, but sometimes surprise is exactly where you should look twice. If you want a single hinge for this whole story, it's the way heat and light will talk to Atlas in the inner system. Sunlight is the most honest interrogator in astronomy. It warms, it pushes, it makes ices whisper. If that whisper gets loud in a way that tracks the sunlight, if the dust flows where the heat says it should, if the spin shifts a little because the jets act like tiny thrusters, then the case for a natural giant gets very strong, and we can set aside the napkin doodles about intent. We'll call it what it likely is, a pristine piece of another system's deep freeze, a time capsule older than our mountains, and we'll treat it with the same respect we give to fossils that tell us what the world was making before we were paying attention. If, however, the light curve stays eerie, and even if the gases that do appear refuse to line up with temperature the way they do for the comets we know, if there are nudges that can't be squared with sunlight pressure or clean, symmetric venting, then we don't pack up the cameras and shout. We do the dull, holy thing science does best. We add new hypotheses and try to break them. Maybe we've stumbled into a kind of ice with bonds that hold on longer than our models expect. Maybe cosmic rays and interstellar dust have sintered the surface into a weird armor that meters out whatever lies beneath. Or maybe we are staring at engineering designed to be boring, because in a dangerous universe, the safest costume is nothing to see here. That last sentence is speculation, not a claim. It belongs in italics in our heads, not in headlines. But speculation, treated like a hypothesis and not a hope, is allowed at the table. The beautiful part is that curiosity pays us back no matter which road Atlas takes. If it acts like a comet, we unlock a library of chemistry from a place the sun never touched. Isotopes, those slightly heavier or lighter versions of common elements, will sketch the family tree of the star that fed it. Ratios of carbon monoxide to water, or nitrogen flavors, or simple organics against complex ones, will tell us how cold really was in the nursery where it formed. That's not trivia. That's a map of how planets cook elsewhere. If it refuses to act, we learn where our theories are thin. We'll tune our detectors for stealthier molecules, rethink crust physics, and perhaps coin a new class of object that sits between comet and something we haven't met enough times to name yet. And if we catch behavior that looks deliberate course tweaks that align with geometry instead of chemistry, emissions that appear only when Earth signatures that repeat like a clock rather than like a melting candle, then the most consequential sentence we'll get to speak is also the calmest. The data are better explained by design than by accident. That's a sentence with a lot of locks on it, and that's good. Some doors should not swing open on a draft. There's a human conclusion tucked inside the cosmic one, and I don't want to lose it. Look at what this one dim speck pulled out of us. It made a global network work as one body mountaintop optics. Desert radio dishes, a gold-plated eye, 1,000,000 miles sunward, an infrared giant, cruising the deep Lagrange quiet, and a steel piano circling Jupiter listening for dust. It made old rivalries share code and time, because nobody's ego survives long against the sky. It made lay people learn the difference between what we saw, what we think we saw, and what we'd love if it were true, which might be my favorite education outcome of all. And it reminded us, gently, that we are very small and very good at paying attention when we feel like it. That's a lovely combination. So here's how we leave it tonight. We know enough to be earnest and not enough to be certain. We're going to watch Atlas roast a little and either sing or stay stoic. We're going to listen with radios tuned to the kinds of tones nature rarely plays. We're going to track its spin like a heartbeat and notice if stress makes it skip. We're going to let Jupiter's radiation give it a loud, harmless shove and see whether its mass and structure answer back the way rock and ice should. And then we'll write down what happened, because the universe deserves a witness who doesn't embellish. If you came into this thinking, please let it be more than a rock. I understand. Romance is the fuel for a lot of long nights at a telescope. If you came in thinking, please don't make this another circus. I understand that too. Responsibility is the other fuel. We can carry both without spilling either. As Dr. Jill Tarter likes to put it, keep your mind open and your standards high. That's the North Star here. When our guest is finally past Jupiter and dimming into the long dark again, we'll take a breath and check the napkin. If it reads natural, enormous, informative, we win. If it reads natural, weird, instructive, we win differently. If it reads with that unnerving calm, not entirely natural, prepare for a lot of very quiet meetings and a very loud century. I'm not promising any of those outcomes. I'm promising that we'll tell you which one the measurements chose. If you'd like to keep the chair warm for that moment, you know how to help me find you again. Subscribe so you don't miss the part where the smudge becomes a story. It's the simplest way to turn this one-time bar chat into an ongoing watch party. And because this channel works best when it's a conversation, drop me one specific thought in the comments. If you could pick only one measurement to settle your gut feeling about 3I Atlas, one observation, no do-overs, what would you choose and why? Do you want a radio scan during the hidden swing behind the sun? A spin state check before and after perihelion? A dust grain analysis in Jupiter's magnetotail? Or something I haven't mentioned because you've got a better instinct than I do tonight? There isn't a right answer. There's only the answer that reveals what you value as proof. And tell me where the next napkin should point. Do we chase Atlas with a thought experiment that turns into a blueprint for a bare bones interceptor we could realistically build, something small, fast, and honest about its limits? Do we take a slow walk through Jupiter's magnetic weather so the March encounter makes more sense in your bones than in jargon? Do we rewind to Oumuamua and Buasav and write the field guide to interstellar visitors we wish we'd had before this one arrived? Or do we go bolder and ask what a designed-to-be-boring probe would actually have to do, and how we'd catch it without scaring ourselves silly? Pick a path. I'm game if you are. For now, fold the napkin and tuck it under the glass. Our guest is still out there, dark against darker, moving exactly as fast as the numbers say it should, and exactly as strangely as our curiosity needs it to. The difference between mystery and nonsense has always been measurement, and we have the instruments, the patience, and the good humor to keep the line bright. Sleep on that if you can. Dream if you want. We'll be here when the next data point lands, ready to sharpen the pencil, and if necessary, order another round.